Klee is a very successful entrepreneur who has been able to transition his life into this higher pursuit of trying to understand the nature of what is. He also leads the Quantum Gravity Institute.
The past no longer exists, and the future obviously doesn't exist. And that was the old school view. And then we realized, as backed by some experiments, that it's bizarre, but the future actually exists. And so too does the past continue to exist. One might say, well, who cares? Why are Robert and Klee talking about primes? Well, primes, everyone, are the essence, right? The skeleton, the core of these important numbers for physics and life, which are the counting numbers, right? That how many of a thing do I have? And the core of them is the primes.
What we're talking about here is what Klee is saying as well, is that the future also determines the past.
Yes.
Cle Irwin, what a pleasure to have you with me here on the Think Tank. I've been so excited to have this conversation with you. It's been since the beginning of the year that I've been excited for this conversation. And maybe even before that, we had a chance to meet at a New Year's Eve party. And, everyone was interested to hear what we had to say for the first 20 or 30 minutes. And then I think we kind of cleared them out because we got deep in some real discussion about math and physics and simulation theory and emergence theory and all these really exciting things. And for those that don't know Klee is a very successful entrepreneur who has been able to transition his life into this higher pursuit of trying to understand the nature of what is. That's kind of the best way I could describe it. And maybe also to seek to understand some of the questions why, and maybe seek some of the answers associated with that. And it's very, very exciting to have him here. He also leads the Quantum Gravity Institute, which is in Southern California. And I'm super excited to have him here. His institute has been responsible for publishing over 120 some odd peer-reviewed publications in physics and probably number theory and sort of spanning several different areas of topics. Yeah. So you become your own little kind of university in a way.
Yeah, a little institute with less politics, because we can explore scientifically anything that we're curious about without being judged by peers who might, at a university, right, who might otherwise blacklist or shun us for having outside the box thinking.
Well, I look at you also as someone who's near and dear to my own heart, because your path and my path have kind of been quite similar in some ways. We were both entrepreneurs who were in business and everything and said, okay, what do we want to do with the world, or what do we want to do with our experience for the rest of our lives? And, I went through a major shift. I was a pharma CEO and then decided to start my own group of companies. And part of that, I got involved with Nassim Haramein, also looking at quantum gravity and the quantization of gravity, and trying to understand the relationship between gravity and electromagnetism and radiation. And you've just been on this path. So tell me, how in the heck did you make the transition? I'm just super fascinated. How did you go from being the successful entrepreneur to that one day that you said, okay, I'm going to work on quantum gravity now?
Oh, well, it was a little bit of a situation that felt kind of supernatural. Let's be honest, the word supernatural means whatever your theory of nature is, if something happens that doesn't fit that theory, it's supernatural. So if we go back to the theory of reality 150 years ago, then the idea that I've got a Wi-Fi signal right now all around me, that is supernatural relative to a theory of physics that was dominant 150 years ago. So anyway, if somebody today claims to have an anomalous cognition event, all right, such as remote viewing that they worked on at Stanford Research, or a premonition, any access to what we call non-local information would today be judged as supernatural, but tomorrow it may be judged as natural. So what happened to me 15 years ago is I was a happy-go-lucky materialist atheist minding my own business and enjoying my life, making a lot of money. And I had a company. We're doing, I don't know, 100 million a year. I was making money. I owned the whole thing. I didn't have shareholders. I was having fun playing Monopoly, making money. And so anyway, so the event that happened is something that you're either gonna think, oh my God, I'm going insane and delusional, or wait a minute, am I going insane, or is something real happening? And what it was it was as though did you ever see the movie Close Encounters of the
Oh yeah, of course.
And remember the fire, yeah, remember the firemen.
By the way, May the 4th be with you.
Thank you. But
Today's
remember
May
how all
4th.
these people, firemen, school teachers, people of different walks of life in the beginning of the movie, they were getting obsessed with that shape, okay? And building
the mashed potatoes and Richard Dreyfuss, right.
Now, if you look at any one of them individually, and you could say, well, they're clearly going insane. That is clearly a delusional weirdo going insane. Except in the movie, they weren't going insane. They were getting access to non-local information. They were being kind of inspired or connected to some field of meaning. And anyway, so that's kind of something like what happened to me. And it felt as though it was, for lack of a better word, versions of myself or conscious entities that are part of a future evolution, right, that had looped back to somehow make contact with myself 15 years ago. And the concept was, well, do you still want to do this program, right, this project, this work, which I had been obsessed with at that time, right? A lot of stuff that we'll talk about here today.
Hi, I'm Robert Edward Grant. I invite you to explore my transformative books, Philomath and Polymath, each designed to expand your understanding of the world and ourselves. In Philomath, which means lover of learning, discover how mathematics weaves together physics, music, and prime number theory, revealing the universe's interconnected nature. It's more than a book, it's an enlightening voyage. Polymath builds on Philomath's insights, exploring the genius of thinkers like Pythagoras and Da Vinci, who used geometry to revolutionize science, art, and governance. Rediscover the polymathic roots that sparked past ages of enlightenment. Join me on this journey as well. Visit robertedwardgrant.com to get your copies today. Let's foster a new era of enlightenment and collaboration for a brighter future.
In a nutshell, to summarize, answer to your question, Robert, is about 15 years ago, happy-go-lucky materialist atheist, I start getting what appeared to me at the time to be anomalous cognition events, where it seemed like I was either going insane and delusional, or I was coming into contact with information, meaning, thought, whatever you want to call it, that was not local to me. And it presented, the meaning was presenting itself as though it was patterns of myself and my friends, maybe whom I don't even know yet, from the future of the evolution of society. And at what point in time in the future, I have no idea. And it was as though it was an invitation to continue with something I had agreed to do. And there was a question that came through at one point: do you still want to do this work? And I said, yeah, I understand what you mean by this work. It's this, this work on a new cosmological model, and, really just kind of synthesizing all these ideas that have been spontaneously dropping into my mind in the last few months, again, 15 years ago, and synthesizing that into a paradigmatic, new view that can hopefully bridge the paradigms of the studies of mind and consciousness, that can even include ideas that one might call spiritual, but that I just call non-local, aspects of reality, with mathematical physics at the most fundamental level. And so then what happened is, I had to effectively become a physicist, right? So I had been an amateur physicist my whole life, like an amateur, astronomer. But I wanted to go full time. So I went full time. I started spending millions of dollars, having a staff of PhD mathematicians and physicists, and we began trying to derive meaning and further advancing on these thoughts that had started to self-assemble in my mind. And now, 15 years later, we have a cosmological model that, called the self-simulation hypothesis interpretation of quantum mechanics, which is agnostic to the type of math and the type of approach one uses. And I'd love to share that with you. And then we work on one application or physics model, if you will, or model of reality that can live within that agnostic self-simulation hypothesis. And that model is called emergence theory. And I'd love to tell you a couple sound bites about that after I break down the gist of what this self-simulation hypothesis is about. So, and along the way, I'd like to give the listeners here an opportunity to understand the simulation hypothesis that Elon Musk, basically posts about, and a lot of legit scientists believe is real. I can explain that in less than 45 seconds by just asking your listeners to mentally answer for themselves 2 or 3 questions, and the answers to those.
Let's go for it. I mean, I definitely teach, and a big advocate. I've been a big advocate for simulation hypothesis for a long time, not necessarily all in the same ways that it would be posited by Nick Bostrom.
Yes,
but I'm definitely a fan of the whole generalized concept of it. And yes, I think Elon has probably popularized it because he was one of the first to really make kind of
exactly
broad comments about it in the
and
media,
and
et cetera.
it's just naturally getting more popular as otherworldly science fiction levels of ultra strong AI come on the scene, as processing continues to get faster, as my son's multiplayer video games are now starting to all of a sudden look photorealistic, right? And
Yep.
all right,
Apple Vision Pro.
yeah,
Apple Vision Pro is anyone that I put Apple Vision Pro on, they literally come away after they take it off and say, "We live in a simulation, don't we?"
Thank you. So it's going to be trending now. So what I'll do is I want to just get the simulation hypothesis of Bostrom and Elon Musk's, as a popular fan. I want to just get that to the side really fast, because the way I'd like to explain the self-simulation hypothesis is by contrast, as an alternative version. So play dumb, and I'll just ask you these 2 or 3 questions, and you got to serve as a proxy for your audience here. All right. So, Robert.
Yes.
So are you willing to say that it's probably true that as time goes on, our computer simulations will get increasingly more realistic until eventually they are indistinguishable from reality? Probably.
Yes.
Okay. And second question, are you willing to say that in the future, when that probably happens, 2 or more of our descendants will probably run an origin or an ancestor simulation of their reality from some origin point that they can pick at a proverbial Big Bang or anything else along the way, or that one will do 2 or more? In other words, will there be in the future probably 2 or more utterly realistic simulations of reality that eventually occur given enough time?
Sure.
All right. So because you said probably to both of those 2 questions, by deduction, it means that you are saying it's probably true that there's at least a 2/3 chance, because you said probably 2 or more, that there's probably at least a 2/3 chance that we are not in the one real reality.
Yeah.
So that means you, like Elon Musk, are a simulation theory proponent. So now let me contrast that with the self-simulation hypothesis. Now, hidden in the simulation hypothesis is a dirty little secret. And the dirty little secret is a religious or mystically inspired philosophy called materialism. So it was invented by the Greeks about 5,000 years ago. It had a lot of very cool mysticism and religious type of underpinnings. And it is essentially a viewpoint with zero scientific evidence. And it kind of goes something like this. Yeah, we do understand that quantum mechanics unapologetically and bluntly says reality is made of information. And yet we want to hand wave that off and say that information merely conveniently describes some fundamental mystical stuff called energy, space-time, and matter. Now, we do not know where those mysterious things come from. We do not know what they are made of. And we do not have any actual evidence that they exist. We have evidence that reality is made of information in the context of quantum mechanics. And so you can see it's okay to, as a physicist, it's okay to take a wild-ass guess. But you have to admit, as a good scientist, where the guest has oodles of evidence in experimental peer-reviewed literature and where it has none. And in the case of the philosophy of materialism, there is flat out zero experimental scientific evidence. It's just a philosophy. The alternative philosophy is that reality is made of information. And this is what quantum mechanics says in an unapologetic way. Now, we must, for the conversation at least, have a working definition of what this word information is. So for us at Quantum Gravity Research, we take a pretty conservative view that information is meaning conveyed by symbolism. For example, a bird language, this natural language, English, zeros and ones and how you can organize them into bytes in packages of 4 bits, and so on. Every single instance of information ever dealt with in the sciences, whether emergent information like the meanings in this conversation or fundamental, bit or qubit information, it's always meaning conveyed by symbolism. Now, what is symbolism? Well, symbolism is essentially a part of symbolic systems or languages or codes. We can just use those terms interchangeably. And a language or a code is also very easy to define, and that is a finite set of symbols, okay, and rules on how you can relate the symbols. And a third ingredient is within the rules, you have to have syntactical degrees of freedom such that it's not just a deterministic algorithm. And English fits all 3 of those bills. So we have about 50,000 words in our language, basic ones. And we have rules on how we can arrange them, and we have freedom. So there's a rule that says, I will get arrested by the English police if I say the dog ran cat. It's against the law, can't do it. But I think the dog ran slowly, even though my training data, because I'm a large language model and a transformer, but I'm biological. And my probability, my outputs as generative biological intelligence are based in large part on my training data, everything I've experienced. So for me, it's more probable that I will say the dog ran fast if you tee me up with the dog ran blank, but it's not guaranteed because I might be in a spicy, rebellious mood and just refuse to say the obvious, and I'll say the dog ran slowly. All right, so reality is like this. We have a fundamental set of letters called fundamental particles, quarks, electrons, neutrinos, and so on. And we have this viewpoint that, like letters, like bits, that in all codes, there's an irreducible symbol, right, or letter. And so we think, in the popular canonical view, we say, okay, reality is made of, this quantity of letters that you can count on your fingers and toes, the fundamental particles, and they have rules and degrees of freedom. For example, we have the Pauli exclusion principle, right? There's things that just can't be done. You can't relate 2 or more particles in certain ways. there's laws, rules, and then within those there's degrees of freedom. And so reality itself, and then you have all languages are also hierarchical, so that your proverbial letters go to your words, go to your sentences, to your proverbial paragraphs. We have the fundamental particles self-organizing into words that you can call nuclei, neutrons and protons. And then those self-organize into atoms, like clauses of a sentence. And then those self-organize into molecules like DNA, like entire sentences. And it just keeps going up and up. And so all language has this hierarchical quality. So
it's funny you say that, because in my trek through a similar experience to what you described with getting, for lack of a better term, downloads.
Yeah.
Right. Starting at about 20, I would say it got really intense from 2014 on, but it started at probably more like around 2010. So it was about 14 years ago.
Mine started in 2010, 2009, maybe 2010. It's about 15 years ago approximately.
Yeah, same with me. Same with me. So it's interesting. We must have been on the same radio frequency a bit or something.
Well,
that's
if
interesting.
The listeners had any idea how much you and I know, that we've got a 95% overlap in our geeky world views and the things that the eclectic signature, it's just too similar to just blow off as a mere coincidence. So I think we same radio.
No, that is super fascinating. And I mean, the point that you're making about all of this, I mean, obviously there's a larger discussion as well about a field of knowledge that probably everyone could have access to.
Right.
That maybe only certain do. And then what are the conditions to be able to get that access to it?
Yes.
Right. But the way you're starting to describe the self-simulation theory, I would say it's freakishly similar to the way I describe it as well.
Yes.
And so we never even had this conversation. So
no, we're going to be finishing a lot of sentences, I think.
Yeah. So it tells there's some sort of proof positive just in that concept alone. So please keep going. I'm super fascinated by this.
So part of the self-simulation hypothesis underpinnings and emergence theory, which is our application of the self-simulation hypothesis, is language theory. And so language, for our listeners, should not be thought of as just spoken languages. Okay,
math is a language. Yeah, math is a language.
And again, a language should be defined as a finite set of objects or symbols and rules on how you can relate them, where there's syntactical freedom within the rules, so that you're not just an algorithm playing out. So physics, particle physics.
That's what I was going to say. I'm a linguist. I speak 8 languages.
Yes.
So I speak Korean, Japanese, Chinese, French, German, Spanish, English, and Hebrew.
Well, that's pathetic, Robert. You only know 8 languages. Why not 10 or 11? Just terrible, lazy.
Well, I didn't want to be categorized as like one of those guys that works at the UN and that's all he does is translate. Nothing wrong with that. Nothing wrong with that. But it's interesting because I saw math as a language.
Yeah.
Immediately, I saw it, and it's very similar to the way you just described it. So that's really kind of freaking me out. Mm-hmm. The way I saw it was I learned a system for learning languages, and the system was to learn the verbs. So I learned 2,000 verbs in any language to learn the language first, because I knew I could be proficient if I knew at least 2,000 verbs. I would not spend any time memorizing nouns or anything like that, but I would spend time learning the conjugations.
Yes.
And, all the particles and all this type of stuff that would go along with the language. And so when I started deeply diving into mathematics, I looked at it from the lens of language, and I found that the words were like numbers. The verbs were the math constants, the verbs of action. Like I'm circling a diameter, for example, and the ing that we append on the end to make a noun into a gerund was like an irrational tail. Right. And so then I thought, well, how many verbs do we know? And a number of math constants that the dimensionless math constants that we actually know and understand, if you include all the physics constants, and those could hardly be characterized as dimensionless entirely because they all are based on, at that time, at least I was thinking that they're all based on certain measurement systems, right? Could be based on, kilograms or seconds or meters or whatever. I later found out that even all those might actually be dimensionless too.
Yeah.
and we're living in a world of ratios. But I looked at it as we only know probably 20, Feigenbaum constant, and a lot of those are derivations of the same ones that could define our world. And so I thought, I wonder how smart we would be if we knew 2,000 verbs, like
Exactly.
literally 2,000 verbs. And that's how you could actually classify the advancement of a civilization would be how many verbs and how many discrete geometric forms does it actually understand and comprehend?
Exactly. So I'm going to riff off your verb. I'm going to look at that as a synchronicity, because I like to lay down these basics for the whole conversation. So I've laid down the basic definition of the word language. Now I want to lay down the basic working definition of the word consciousness. And I'm going to use the concept of nouns and verbs. So a false question would be looking at a wall clock and saying, well, what number comes first? The 10 a.m. number or the 4 p.m. number? So you wouldn't want to ever answer that. You'd want to say, well, that's a false question.
That depends.
If you're putting it on a line and you tell me that the left side of the line is where the beginning is, then I can tell you what comes first in a sequence of numbers. So it is a false question to ask, what is consciousness? And what I mean by that is consciousness is not a noun. Consciousness is a flow, a process. It is story in motion. Consciousness should be described by its verb forms. So the verb form of consciousness includes many equivalent verbs. It includes the verb think. It includes the verb idea of to perceive and experience meaning, right? It is a constant story of awareness unfolding. And you might object by saying, well, Cle, what about if I choose the state of consciousness of pure nothingness or everythingness, okay, with no duality, okay? And I would say, is that not a choice of a state of awareness to be aware of non-duality nothingness or everythingness or the void? And if you admitted, well, I guess I did choose that, and I'd say, well, then that is yet another choice of a state of awareness that you have chosen to be in. And you may choose at another step to be aware of something, something more finite or dualistic. So if we allow this softening of the meaning of consciousness to be extended out to the words meaning, awareness, thought, and we don't have to grapple in and get too detailed about debating. We can just say there's also a bit of a mystery to it, because consciousness itself emerges from such an enormous magnitude of complexity in complex systems that it becomes part of the class of problems that computer scientists, describe as non-solvable. There are unknowable problems in a finite universe that even if you
these are NP hard.
There's NP hard, which is one class, and then there's purely unsolvable. But it depends. So there's that. So now let me, with those little definitions, just for sake of the conversation, let me try to be concise and explain the self-simulation hypothesis, because we've explained for your listeners the simulation hypothesis and how reasonable it is. In other words, Elon Musk is very reasonable in deducing that at least, there's a 2 out of 3 chance that we're not in the one real world. But I had mentioned the insidious assumption of the ancient Greek spiritual tradition of materialism, right, being baked into that question that I took you through, because I was dishonest in how I asked the questions.
Okay.
I said, so therefore you believe, Robert, that there's only a 1/3 at best chance that you are lucky enough to be in the one real reality, because the other ones made of pure information, I implied that they were not real. So I implied that I am a materialist and I kind of tricked you to going along with that by not being honest enough to say, and by the way, this may be a false assumption that there is anything other than meaning or information to reality. So now let's go to the contrasting self-simulation hypothesis, and I'll kind of do it with the same way. I'll just ask you to play dumb and answer a few questions, and feel free to say probably or yes. Okay. So question 1, even if you cannot describe it mathematically, physically, even if you can't prove it, are you willing to say that you are probably conscious, even if you can't fully define it?
Yes.
So that means you think consciousness exists, like it's a real thing in this reality. Okay, good. That's important. Me too. Second, do you think that your consciousness as an exceptionally smart human is anywhere remotely close to the upper limit of what consciousness can be, either in form or magnitude, within the laws of physics and quantum neurobiology that we know today, right? We probably would say, no, we're not thinking that we're at the apex, the upper limit of it all. All right,
no, definitely not. The more I learn, I feel, the more I less actually know.
All right. Let me me ask a third question. Are you willing to say you don't have a big problem with the adage from physics that says whatever is not strictly prohibited will occur given enough time?
I even think the things that are strictly prohibitive will occur given enough time.
Okay. So then, so I can go that way too. But we can say that since
the answer is yes to your question, yes, definitely.
Because we teed up the other one to say that, given the laws of physics and quantum neurobiology, right? Should we believe we're anywhere near the upper limit, right? And so we said no, and then we're saying, okay, sticking to the laws of physics and restricting ourselves in that way. This is the laws of physics as we know it today, which will probably be overturned, right, as they always are.
Yep. Mm-hmm.
So then we can say, yeah, given enough time, there's definitely far more advanced forms of consciousness and magnitudes of consciousness forward in time. And we can say that probably can exist in our descendant tree. And our descendants are mostly speciated away from us, right? Like there's been 100 million species on the planet so far, according to the standard evolutionary biology theories, and they all just branched off or speciated from one another. So our descendants will surely branch off and speciate from us, but we could still call them our descendants, and they live obviously in the future. And I think we could at least, I don't need to ask you to add this question to your list, but we'll just kind of say to our audience that you and I believe that there's some truth to Einstein's idea that the future, past, and present are equally real. Prior to his theory and the experimental demonstration, it was popular before 1905 to believe that the past no longer exists and the future obviously doesn't exist. And that was the old school view. And then we realized, as backed by some experiments, that it's bizarre, but the future actually exists. And so too does the past continue to exist. So in that context, we can say right now, there are probably descendants in somewhere in deep time or even near future time that are sophisticated enough to hold within their consciousness, whatever that word means, a simulation of themselves, the whole origin. So now I'm going to ask you to let me run a simulation in your neural network. You might need to close your eyes because I'm going to ask you to play the game of tic-tac-toe against yourself to the end, and then announce to the audience and me whether X's or O's won. But first, I want to set up the metaphor to serve my purposes, because what we work on is the concept, metaphorically, of game boards and games. So the 64 squares on a checkerboard can allow you to play a bunch of games, and games are algorithms. So you can play chess on it, or you can play checkers, and you can play a lot of other games. But they're different. The game board and the games are different. So for us, game boards are algebras, and you can represent certain types of algebras with spaces that have points in them. So, for example, we can have a space in 2D that has the vertices, the little points that are where the lines cross on a checkerboard. And we can imagine that checkerboard going to infinity and having those periodic points arranged as they are. And that is a mathematical object called the Z2 lattice. And these lattices are often part of the skeleton, if you will, of algebras called Lie algebras that physicists use for physics. So I'm going to ask you to hold within the substance of your consciousness a very, very small section of this infinite Z2 lattice, a tic-tac-toe board, just 9 squares, 3 by 3. And if you need to close your eyes, do it. If you don't, but lay down the first O, and don't tell us where it is, but you're going to have to hold it in your memory. And then lay down the first X. And then lay down the next second O, and just play the game of tic-tac-toe out to the end, and let us know whether X's or O's won.
Okay. X is 1.
Excellent. You're smarter than me because I have to close my eyes to do it. And that's not surprising because you're very smart. So now imagine in your descendant tree, a bigger consciousness can play on a higher dimensional game board, such as the point set in 8 dimensions of the E8 Lie algebra's root lattice. It's very much like the checkerboard. It's just a periodic array of points in a space, right? Like you could take the checkerboard to 3D and you could like kind of rise it up into a cube with little points inside of it. And so this is no more complicated than that. It's just raising it up a few more dimensions to 8D. Now, that's a game board. So a big consciousness, like the Borg from Star Trek, right, a bigger consciousness, could in principle hold a much bigger section of a higher dimensional game board. And it could run a game or a simple program that is more sophisticated than tic-tac-toe. Certain games can produce probability distributions for how game quasi-particles, which are ripples, patterns, can emerge as the game plays out. Stephen Wolfram, a friend of mine, works a lot on these ideas of how simple programs can make shockingly sophisticated dynamic patterns. One example that some of the listeners here have probably seen is you can go on YouTube and Google like 4K fractal zoom, and it takes you into this otherworldly system of patterns that never quite repeat. And if you look, if we showed our audience the tiny simple program, the little algorithm that generates that, they'd be blown away. They'd say, well, how can such a simple little algorithm do that? And it comes from large quantities of iteration. And that's what's happening with GPT-4 and all the other large language models and the generative video like Sora and the generative music. All of this is artificial creativity that happens by taking an incredibly simple concept of the math of neural nets and just going nuts with the quantity of iterations, and then you get this emergent complexity. So, long story short, the self-simulation hypothesis says consciousness seems to exist, so we probably don't need to argue too much about that, because I think probably less than 1% of scientists would deny that they are conscious.
Did you know that there's a new love affair with mathematics and geometry happening all around the world today? People who once despised these subjects in high school are now finding they're falling in love with them. Do you know why? Because math without meaning is simply information. whereas math with meaning is divine communication. My courses, The Etymology of Number and The Language of Light, guide you on a journey of self-discovery, sharpening your problem solving and pattern perceiving, as well as analytical and creative thinking, and unlocking your fullest polymathic potential. And most importantly, acquainting you with the mathematical language of the universe itself. You will never see the U inverse the same again. To get started, I recommend The Etymology of Number, a 4-part series that explores the evolution of numbers and their impact on fields like physics, chemistry, music, and art. It is the embodiment of Leonardo da Vinci's encouragement to study the science of art and the art of science. Learn how to see. Realize that everything connects to everything else. My second course series, The Language of Light, is a 6-part series that builds on concepts from the first course and offers deeper insights into unified sciences, ancient wisdom, spirituality, and their relevance to today. My courses are always fun and easy to understand. They intertwine mathematics, music, art, and consciousness, and illuminate the mathematical connections that span all disciplines of science and art. Register for these 2 courses, Etymology of Number and Language of Light, at robertedwardgrant.com under the Courses tab. And join the Robert Edward Grant community chat on Orion Messenger for lively, engaging, and innovative discourse.
And so we can say consciousness exists. Consciousness will most likely get more powerful, and we are probably not the upper limit. Consciousness can run simulations, like you just ran the simulation of the tic-tac-toe game. And the sophistication of the simulations linearly maps to the sophistication and the magnitude of the consciousness running the mental simulation. So in that picture, we can run the same simulation that we agreed could be run in the simulation hypothesis that creates utterly realistic, realities. And we can also do it within a mental framework because we have evidence that computers exist. We have evidence that consciousness exists. We have evidence that consciousness can run photorealistic simulations. So tonight, I'll probably have 7 dreams, and I will be punked, like my kids say, by all 7 of them. Meaning, I will never stop in the middle of my dreams tonight and ask myself, wait a minute, I know this is utterly realistic, but am I dreaming? Is this just a mental simulation? I have done it, and I've had lucid dreams, but I probably won't do it tonight. And I probably will not do it on this call with you, Robert. So far, we've been on this call for many minutes, and I have never once asked myself, is my dreaming this as a mental simulation, or is this a real call with Robert? Because how would I know? And the reason I don't ask myself that is because I constantly get fooled, punked by the utter realism of my mental simulations and dreams, and I cannot tell the difference. The way light triangulates off of a dream chandelier, if there was any funkiness, my pattern recognition ability would see it as wonky, and I'd know, but it's really accurate. So long story short, currently dreams are outpacing man-made computer simulations for sheer realism. But that's okay, because in a very short period of time, the simulations created by mankind in computers will be equivalently realistic. So now you've got 2 horses, candidates. Is reality, if we believe in the simulation hypothesis, is it a mental simulation, like in the self-simulation hypothesis, because there's evidence for consciousness and no evidence that we are the upper limit? And there's evidence that computers can run simulations, and there's no evidence that they are at the upper limit of what they can do. So that's the self-simulation hypothesis. I'm going to go with saying that the self-simulation hypothesis is more probable than the simulation hypothesis, because the simulation hypothesis has insidiously baked into its bones the nasty little mistake of 5,000-year-old mystical Greek materialist philosophy. and I see no evidence for that. And quantum mechanics says boldly that reality is made of information, that there is no real information. There is no world that is
Right.
not made of information, right?
Yep.
So now I get to the paper. So we published a peer-reviewed paper in a physics journal. It's our institute's most popular paper. We've been around 15 years. Our scientists are mostly PhD mathematicians, computer scientists, and physicists. And what this crazy worldview is, and as Einstein said, a theory needs to be just crazy enough to be true, right? And if it's too timid and too kind of run of the mill, probably that's an old school theory that needs to be overturned. So this idea here is that we are living in a mental simulation within the mind of an emergent pan-consciousness substrate. So when you imagine a pan-consciousness, right, that is essentially the idea like the Borg in Star Trek, but you are one of those Borgs. So you're made of countless billions of little animals that are like sperm. They are single-celled organisms. They run from toxins. They chase nutrients. They make unpredictable choices. They have babies, and they go to the bathroom. Cells. So your body is a vast city of cells performing different roles, like carpenters and doctors. And they're stupid compared to you. So Robertness is a sort of difficult to define quality that emerges and floats upon an ocean of trillions of these little animals. Down below, the little animals live their little lives, make their simple choices, and they have very little idea that there's this godlike emergent Robertness, right, floating and steering them, right, steering your body to move left or do right or eat this or that. And so we can say that that's downright miraculous. There's nothing in quantum mechanics that we know of that predicts that, because we cannot use quantum mechanics to predict the probability of anything more complicated than a hydrogen atom. We can't actually apply quantum mechanics mathematically to a DNA molecule or a calcium atom, and much less, Robert's entire complex system. So, but we do have a lot of authors who have explained that the probability for life and Robertness to emerge just by quantum mechanics is probably a snowball's chance in hell. And yet here we are. So with the self-simulation hypothesis, we require another implication of experiment and quantum mechanics, which is retrocausality. So in the classic Newtonian view, we say that if event A caused event B, it would be impossible or illogical for event B to have caused event A. In quantum mechanics, the way
it has to go both directions.
Yeah, but the way the math works in quantum mechanics is it goes both directions in time. So it says if event A caused event B, it allows just mathematically for event B to cause A in a simultaneous co-creation. Then there's experiments that corroborate that. And it's hard to accept because the world around us...
Yeah, this is like the quantum eraser.
Yeah,
the quantum eraser with Nerval slit is a good example of
it. Yeah, John Wheeler invented that experiment, and the technology to demonstrate it did not emerge until after he had died, I think in the 90s.
Yeah.
And he would be happy to find out that his experiment turned out to be, positive or true when conducted. So long story short,
just for my viewers, what that basically means is that we all kind of understand the notion that probably the past and the present has something to do with the future.
That's right.
And what we're talking about here is what Cle is saying as well, is that the future also determines the past.
Yes.
Because we have an electron-positron coupling, right?
Yeah.
And this is, I think, you probably heard about this experiment. I'm not sure what the status is, the one that they were going to do at University of Portsmouth on annihilation of gamma photon annihilation using electron-positron coupling to basically annihilate each other and prove information theory, which definitely seems like an interesting experiment. I don't know if they've done it yet or not. I know
Yeah,
they were going to do it.
it's fascinating.
Um,
So with we call this retrocausality. It just means,
mhm.
causality coming from the future, acting on the past. But it doesn't mean that we deny normal forward causality. Now you take both
It just goes
causalities.
both. It's a two-way street, at least.
It's a guitar string. It's a
Hmm.
feedback loop.
Yeah.
It's a
Hmm.
co-creation between future and past. I mean, let's personify it. Let's agree that Einstein is correct and that there's a version that Robert exists tomorrow on Sunday, right? We're
Yeah.
recording this on Saturday. And the probability that you're going to die tonight is exceedingly low, which makes the probability that Robert exists on Sunday, tomorrow, exceedingly high. And so the Robert tomorrow, in this viewpoint, is subtly influencing the Robert of the past, which is today. But the Robert of the past is right now nodding his head in agreement, which is changing the Robert of the future. Every little thing that the Robert of today does changes Robert tomorrow, and vice versa. So they are in a co-creative jam session, in a sense, co-creating each other. And if all of reality, from a particle system like you just described to a human complex system of two versions at different locations in time, but where does it end? What about the Robert on Monday? What about the
Totally.
Robert as an old man, of a wise old man of age, 70? They're all co-influencing each other. They can be manipulated. You can
Hmm.
minimize or dampen the influence from one of these other influences forward or backwards in time. You can dampen and you can upregulate, right, the power or the amplitude of that influence. So what I have done is I have zeroed in on aspects or pathways in the probability distribution forward in time, the ones that I like or the ones that I sense are pulling like strange attractors on me, and I embrace them and I seek to resonate with them, and in so doing to upregulate the probability, like amplitude, right? And
Sure.
so
Yeah.
and
Mhm.
so that is a way that you can participate in the co-creation of reality and your own life or your scientific project or your business project. You dial in to those pathways forward. You can just use your imagination to do it, and you fixate on that, and you just pretend what it would feel like to literally quantum couple or interresonate, and in so
Hmm.
doing you tweak the quantum probabilities of flowing down those pathways. Kind
Right.
of, you can imagine your favorite TV science fiction show about many worlds, right? All these many
Yep.
worlds of quantum, and then in this sense, it's kind of like picking one of those many world pathways that are allowed in quantum mechanics and using a kind of mental connection to create the guitar string of the feedback loop, and then that actually makes its way down to the particle level, where quantum particles are having higher magnitudes of quantum resonance and
Yep.
coupling. So finishing the explanation of the self-simulation hypothesis, so we can talk about emergence theory. One could say that it is agnostic to what the actual mathematical approach is and the physics that can be applied. It's an open cosmology that allows lots of models like what we work on, emergence theory. So let me cap it off. The self-simulation hypothesis is like a line that you say, event A, like the Big Bang, led to the early hydrogen universe, right? Led to the universe of just suns before supernova. So there weren't any other atoms in the universe other than hydrogen mostly. And then supernovas started to happen around here. And that spewed out about 100 different types of atoms like iron. And then molecules could emerge like, DNA, and simpler molecules like H2O. And it just keeps going, and it gets more and more and more complex. Life emerges eventually, societies, stock markets, this heady conversation we are having itself. And now, so then on that linear spectrum, we get to this object here, which is really simple, like the game board, the mathematical game board and the mathematical game. And then this way up here, Robertness, which we gave as an example of something wickedly complex, that float emerges from an ocean. And then beyond Robert, these higher magnitude and even different forms of consciousness, where we admit that eventually you get to one that was capable of holding the game board and the game and the whole evolution playing out as a self-simulation. And all we have to do to make sense of this is give up the question, what comes first, the chicken or the egg? The question of what comes first was never meant to be answered. It was a parable to explain what a false question is. You don't ask on my wall clock, we don't ask what comes first on the circle, the 10 a.m. or the 3 p.m. That's a false question. They're on a circle. So if we take this, if we reject linear causality, and there's experiments, quantum mechanical experiments that allow us to reject it as scientists, and we just wrap that line in a circle, we have the metaphor of the Ouroboros. So the Ouroboros is a symbol that showed up in countless...
the snake eating its tail.
Yeah, and the tail represents the thinnest tip at one skin cell. It's not very complicated, it's not very big. And then as you get all the way up to the head, it's the biggest and most complicated part of the snake. And so in self-simulation hypothesis, we can ask, well, where does the game board, the math game board and the algorithm at the origin, where did that come from? Where does it live? And we say, oh, that comes from, lives within and emerged from the mind of God. And we can say, well, where does the mind of God come from? Follow what we know about evolutionary biology. Like, you get to ridiculously abstract thinking creative engines like Robert, and then you go beyond that, and you don't have to subscribe to the old school idea that a consciousness like Robert can only exist in carbon-based matter. Why can't Robert consciousness patterns exist in the electromagnetic spectrum? Why can't it exist in gravitational patterns? Why can't it exist in some exotic topological form of physics like Leonard Susskind's idea?
Or the periodic table of elements.
Thank you. So that's it. So it's just the wrapping of that linear hierarchy into a circle. And then you can ask, oh, the self-simulating pan-consciousness substrate, which is like God, right? I'm not trying to be religious. I'm just saying it's more probable than not that higher and higher levels of consciousness can self-organize in the universe. And eventually you get to ones that can do simulations better than tic-tac-toe. And even simulations better than the dreams that keep punking me. Because they're way more complex than tic-tac-toe.
I bet you have some trippy dreams, man. I'm quite sure you have some wild trip. I could see you waking up and going, that was a trip.
Yes.
That happens to me all the time, by the way. And by the way, unlike what you said for you, I was thinking during this course of this conversation, not even wondering, I'm like, whoa, this is a trippy simulation. as it's 1:44 right now.
We need to do that. We all need to do that more often. We need to stop and ask in our dreams, because if you get used to stopping and asking if you're dreaming, like if you train yourself to ask.
I do it all the time, yeah.
Then you're going to have more lucid dreams. And if you can have a lucid dream, you can do some really cool stuff.
So I had this weird experience this week. I spent the week in Austin, Texas. I stayed at the house of a pretty well-known actor by the name of Adrian Grenier, who was the guy who played the lead character on one of my favorite TV shows of all time, Entourage.
Oh, yeah.
And so I spent the week at his house, and he's an incredibly gracious host. But it was so bizarre for me because I've been studying alchemy, and I'm kind of a student of Hermetic wisdom, and I happen to believe that the self-simulation hypothesis that you are putting forward here has been taught for millennia, from ancient times to today, just using different words. And, the very first principle of Hermetic wisdom is the universe is mental, the all is mental.
Yeah.
And I think it's such a powerful thing. So I teach Hermetic wisdom, and I get to his place. And this whole last few weeks, I've been really intrigued by the concept of philosopher's stone and turning the suffering of negative experiences into the evolution, the gold of evolution in our soul. So it's soul evolution.
Love it.
And so I arrive at his ranch. He's got a beautiful ranch. And the name of the ranch is Kintsugi. Now, Kintsugi, you may recognize, it's a Japanese word for making this type of pottery of broken pieces of pottery that they put back together. They take all the broken parts and then they weld it back together with gold.
Yes. Something
so it's
beautiful
like
from something
it's
broken.
something beautiful from something broken. And to me, that's the hero's journey that, I believe is the foundational basis of the entire self-simulation theory that you're talking about.
That's right.
And I believe that we have a higher self, and the higher self is basically decided for us to experience this division of oneness so that it can perceive itself through our eyes that are totally unique, that nobody else would ever have had in the past and no one will ever have again, because we have our own unique conditioning biases associated with it. So even though we think that what happens to us is what happened to us, it's not. It's what we believe happened to us that actually happens to us. In our minds, it creates an emotional state. And then those emotions feed some larger, for lack of a better term, AI, which is not really an AI, it's just intelligence. It's feeding back to this one consciousness, and we are like a mirror for that consciousness. And
That's
so,
right.
and that mirror happens right at fine structure constant, 1/137.
I love it.
To me, it's like we have been selected in a way to experience this lower dimensional or dimensionally limited avatar state. We are in a dimensionally limited avatar state because if you and I were omniscient, omnipotent, and omnipresent, we could never play poker and have it be fun.
Yes.
Right? I would know the hand you're going to be dealt. You would know the hand I'm going to be dealt. It'd be kind of boring. So the only game that would make sense in this self-simulation hypothesis would be a game where we limited our powers. And the whole idea was to go back and realize that we had them all along. So the one divides itself into the many simply for the joy of perceiving itself through our unique eyes of perception and then becoming one again. It's like breathing.
Now, let me disclose where the self-simulation hypothesis might bother some people. And I think it's good to face something that bothers you so that you can be a good discoverer in this reality and be a good scientist, because a good scientist doubts everything, even their own beliefs, and always looks to double check themselves to see if they're missing something. So there is baked in, especially for us people in the West, a Judeo-Christian type of belief system, which is also baked into the Islamic belief systems, that says essentially there is this God character, and God was in a good mood. Thank goodness. Thank God, God was in a good mood, and God blessed reality with the gift of reality or creation. And it certainly didn't need us to become itself. I do not believe in that. I believe in a oneness universe where God self-actualizes itself from fundamentally simple things down at the most boring, geeky level of the math game board and the math game. And then that creates a hierarchy of information that is built on sacred geometry, because the E8 root lattice, which is the largest exceptional Lie algebra, is nothing more complicated than a higher dimensional version of this sacred geometry. And I just use sacred geometry to be poetic, and because that's what I like to draw correlations. But long story short, this idea is sometimes rejected by spiritual people who feel it's sacrilegious for me to say that God itself in this worldview is good enough to be godlike without being infinite. Because if something is infinite, if a consciousness were infinite, then there would be nothing new under the sun. There would be nothing novel that it could learn. It could not expand. It could not grow. But a collective consciousness substrate, as the computational substrate, that is itself eternally reaching toward the infinite, is a more beautiful concept that is godlike and spiritual-like. And look, it's kind of like money. If you had $1 trillion, it's about the same as an infinite amount of money, because, you know, I'm not going to live long enough to spend $1 trillion if I even tried, right? So the point is a God that is trillions upon trillions upon trillions of times more conscious and expansive and non-local than me. I don't even, you know, right? Like the word infinity itself is an abstraction. It implies that you can't even add one more little unit or increment.
Yeah, I mean, 2 times infinity is still infinity.
Thank you. So long story short, that's the one disclosure, but I think it's a beautiful realization for me that as a former materialist atheist, that now I actually do have a viewpoint that is feeling helpful to my life, like the way spiritual things do, but it went through the lens of my reasoning, my knowledge, my pursuit of knowledge, and my doubt. And all it requires is that this godlike thing not be outside of creation and reality. It's part of it, and life
Integrated, yeah.
and it's evolving.
The whole universe.
It evolves. So that's that. So now, if you want, Robert, I'll summarize that whole thing in a sentence where, in the self-simulation hypothesis, reality follows the first of the Hermetic principles, all is thought, and thought is synonymous with consciousness because it's kind of like...
And Thoth. Thoth is thought.
It's kind of like the verb form of the noun consciousness, same thing to me. All is thought. And so we have 2 classes of thought in self-simulation. What we call emergent physical information, we write EP. And EP comes in a hierarchy that's evolutionary. So EP1 would be a photon, a neutrino. Okay? EP2 would be a nucleon, a proton. And it goes up. So it's EP1, 2, 3 to N. And then somewhere at very complex systems of physicality, or EP, intelligence comes out of animals like you and I. And this intelligence is not part of EP. Like when I think of irony, right, that is not part of EP. Yes, my mind, my neural network itself emerges from EP, right? And EP is helpful for our listeners to be thought of as geometric, right?
Yep.
Like imagine tiny Planck scale. The Planck scale is the pixelated scale for physicists, where you cannot divide a moment to be less than the Planck moment, and you cannot divide a volume to be less than the Planck volume. They are very, very, very small, and everything physical is emergent from those constructions. So so EP, physicality, is made of mathematical information in the space of geometry, vectors, angles, things like that. And then EC is a bit more ineffable, and it's more abstract and a little bit less knowable, and it emerges on the ocean of EP. And then eventually we find, well, where did EP come from? Like, where did this geometry or these thoughts and these structures of particles, electrons, come from? And that's the Ouroboros. Well, that came from the EC, but the EC has to be smarter than us. Like we're damn smart, right? But I think to make a full-blown model realistic or plausible, you have to imagine somewhere in our descendant tree, and it may not be that far away as things can exponentially evolve. So that's that. And then what really excites me and what drives my life and my mission and how I want to spend my money, you know, after I sell some of the stock in my company and just lean in with the rest of my life to communicate and develop emergence theory. So I can start, but this is your podcast, so I have to ask what you suggest. But I could start by telling your listeners what the axioms or the assumptions, the starting assumptions are of emergence theory. So then the first axiom
yeah, go ahead and take us through the starting assumptions of emergence theory.
Okay.
And don't be afraid to connect it, as much as you feel helpful to things like, Hermetic frameworks.
Please, thank you. Well, then the first one I'll start with, there are 7 Hermetic principles. And so there was a character in ancient literature called Hermes, and this seems to be a different name for the other character called Thoth. And this character also kind of shows
Can I just ask a quick question?
Yeah.
When did you start getting into the whole Hermetic thing? Because I'd be interested to hear how you got pulled into this line of philosophical thought.
Well, this is something that I'm even hesitant to say on a podcast that's going to get published on the internet, but I'm going to do it anyway because I don't want to be judged too much. I try to appeal to atheist, materialist scientists because my goal is to bridge the world of modern fundamental physics with the intuitions that more than 50% of Americans have had, where they have claimed to have experienced anomalous cognitive experiences in consciousness. So I'm going to do it anyway, though, Robert.
Go right ahead.
And so at the beginning of this, so I call this 15 years of my life the mission, right? The mission is just the unification of spirit and matter, but not writing a popular audience book that mashes up phrases like quantum with spiritual words. There's a lot of excellent guys like Deepak Chopra and who's a friend of mine and others who do a great job of that. I kind of want to put more teeth in it because I want to scoop up more materialist atheists like I used to be into this exploration if they're open-minded. And so anyway, 15 years ago is when it started, and that first year, I decided to go to this workshop by this guy.
Can I ask how old are you?
So I'm 58 and I was 44 at that time.
Yep, I turned 55 in about 2 weeks.
Okay, so very similar age, and we both had this activation, if you will, into our mission
around the same time.
At about the same time. So I'm tuned into that radio station. Concepts like sacred geometry or just geometry in general, I don't have to say sacred, but this was coming up as I was tuned into this proverbial radio station that
it's funny you say that because for myself, I used to say, yeah, I like geometry. I was always good at it. And I'm like, but what makes it sacred?
Yeah, exactly. And I think
what's the sacred thing?
And I think it's just sacred now that I, 15 years later, realize that the symbolism, we talked about symbols, right? The symbolism that nature uses for this self-simulation are what we call vectors. So if I take an equilateral triangle, right, it's just 3 lines. But down here at one vertex, this is a vector. This is 2 vectors, right, here and here. And so a tetrahedron, a square, right, these are made of these vectors. So, and this is the language of physicists. Physicists will often use vector algebras. So long story short, this was, so that would be sacred. In other words, if the very ground of reality is thought and the fundamental thoughts are these geometric thoughts, like the idea of a shape or an angle, like when you think of square, that's a very mathematical object, but it's also, when you're thinking of it or visualizing it, it's just an object within your consciousness at that moment. Yeah. All right. So this is the part that I have some reluctance to share, so I'll be quick. So this guy who's an American who gave himself a new name, like a lot of New Age guys do, he calls himself Drunvalo Melchizedek.
Yep, now, I know Drunvalo.
Yeah, so I had never heard of him because I was just going through this phase transition at that time in 2009. But it talked about geometry, and it was a lot of the geometry that was coming through in this, these experiences I was having. So I grabbed some of my crew, my employees, and I say, all right, well, let's fly out to, Sedona and let's go to this guy's workshop. He's talking about this geometry stuff. So we go out, met him. Him and I started kind of resonating, finishing each other's sentences. He invited himself out to my house. I live in Topanga, California. He comes out a couple weeks after his workshop in Sedona, and he asks, we go on a hike, and he asks, hey, do you want to let me put you under a light hypnosis? And I said, yeah, but why? And he says, I don't know, we could just kind of get to the core of what this experience is that's happening to you. And I said, that sounds fun. Let's do that. So he does some light standard hypnosis on me. And, so then that helps me get into a hypnagogic state where you kind of let your mind just be a little bit more expansive. And in that hypnagogic state, he says this weird question: who are you? Right? Like, it kind of implies, like, are you being influenced by something? Is there a core element? Is there a soul element? Whatever. I didn't know what it meant, but it was something like that. And I'm in a hypnagogic state, so I'm not like in a normal state. And my mouth is trying to move, my eyes are closed, and I pronounce this word: Thoth. Now, at the time, I had never read any of the literature. So I had never been exposed to any of this stuff at that point, because I just thought all this was bullshit. Like, I'm a materialist atheist, so why would I ever pay attention to any of these ideas? And this ancient stuff, whether it's Egypt or any of that stuff from where Hermes, Thoth, all this stuff, all that's bullshit too, right? A totally closed-minded mentality. So I just didn't know it. So then later he said it really sounded like you were pronouncing the word Thoth. And do you know who that is? I said, never heard of it. It sounded like a mispronunciation. So I was like, maybe it's Troth, because you want to put a TR after a lot of English words, right?
Yeah, totally.
So I was like, is it Troth, Thoth? Anyway, so I have a viewpoint that, from the self-simulation hypothesis, that different gestalts of consciousness, different entities living in the future, living in the past, it all bleeds together in a kind of non-local field where you can dial in different magnitudes or intensities of these inner bleeding together. So I guess the way I'm describing it is like, oh, of course, I'm not Thoth. I'm Cle Irwin. I was born in 1965. I got my problems. I'm, my idiosyncrasies. I'm not Thoth or Hermes, but I, for whatever reason, was able or willing at a subconscious level to be permeated a little bit or influenced by that gestalt of thought. And this was a form of thought from ancient periods where it is as though at different cycles of time in the last many thousands of years, there have been these sweet spots in time where humanity had the ability to rigorously connect this idea of the unification of spirit and matter, all theories of mind ideas with all theories of physics. But this last wave, and a lot of people believe that these waves are part of these cycles that relate to real physical cycles as our star system rotates around this particular arm of the Milky Way galaxy and other star systems. And it's
which, by the way, is the Orion arm.
Yeah, that's right, the Orion arm. And it's fascinating because for Egyptologists and people who study Mayan and all these connections, it's really fascinating because these ancient people did not have the astrophysical technology to measure 26,000-year cycles. Like, their cultures didn't even last that long. So how in the world, through the astronomy of that day, that they got this knowledge of this cycle around Orion? Mm-hmm. I think they had to do it with a little bit of psychic ability, for lack of a better word. I don't think it was solely just their math at the time. I think it was a mix of some clever math at the time, but I think that they got some of that clever math by intuitions, or, call it downloads. So anyway, so long story short, I believe, Robert, that at different periods of time, we have these peaks in the field. Let's use a geeky word. In the quantum field, we have phases that relate to the cycles of our solar system, to this local part of the Milky Way galaxy that are well understood by astronomers, and they may correlate to things that are less well understood, where the potentiation for an expansion of science, mathematics, and awareness and knowledge is heightened, and then it subsides, and you got to wait to the next cycle.
This is what we've called historically Renaissance periods.
Yes, a period of the quickening, right, is another one of these phrases.
Mm-hmm.
So we're in that
illuminations.
Yes. So long story short, I believe that the first of the axioms is all is thought. That's the first of the Hermetic or Thoth-based principles. So for the listeners, the idea that these two characters are somehow the same consciousness and may have existed in human forms at different times. At the Egyptian level, 4,000 years ago, the entity or the consciousness, which may or may not have been embodied in a real human, that's called Thoth, Thoth. And then at a later epoch, more close to our Western civilization period, we have this character that shows up named Hermes, Hermes. And so the seven Hermetic principles, the first one is all is thought, which is the basis of the self-simulation hypothesis. And it's also what quantum mechanics implies, where it says everything is information. But information cannot exist without an entity capable of actualizing it into meaning, because information is meaning conveyed by symbolism. So the next axiom, and axioms for the listeners are just assumptions, right? So we have to start somewhere, and when we build a physics theory or a mathematical proof, we start somewhere, and these are the axioms. The second place that is an axiom of starting is the axiom of finiteness. So one must make a choice if they're going to build up a cosmology. Do you think that reality is infinite? And are you even able, as a layperson, to define what mathematicians mean when they say infinity, right? Not you, Robert, but I'm saying one has to ask. And so without getting into that, I want to say that most physicists agree in the Big Bang cosmology. And in that cosmology, it is not a cosmology that says reality is infinite. Now, some physicists have models that say it's infinite. So let's just for now agree that it is beautiful to say that reality is infinitely reaching toward the infinite, but hasn't quite arrived. And that means that the adage that there is nothing new under the sun is false, and that there is always opportunity for learning, new humor, right? New ideas, creativity is never ending. All right, so now the axiom of finiteness is going to lead us to a few interesting places. It not only means that reality cannot be finite, and that the pan-consciousness, godlike, emergent substrate is not quite infinite, but always growing. But it also means that in any small volume of reality, like a cubic inch, you cannot have an infinity of points because of the axiom of finiteness. And that leads to the idea that physicists call discrete. So we say that reality is discrete, which means pixelated, that time and volume cannot be smaller than the Planck time and volume. And this is going to lead us into computer theory soon. But first, let me get to the code theoretic axiom, which is the third of our axioms. And that is a really simple axiom. It says reality is made of language. And earlier in the call, we talked about how quantum mechanics.
Yeah, we talked about language.
Right? Quantum mechanics is formally a language. Mathematics is a language. A lot of physicists think reality is made of math, the information of math, and that's a language. We're trafficking in language. You could, by the way, be raised in a forest and never have been exposed to a natural language like English, and your thoughts will have a language, algebraic language kind of form. In other words, you'll have verb thoughts, you'll have noun thoughts, you'll have thoughts of conjunctions that are, I have two rocks instead of one, and that creates what we call a generalized algebra. So all thought is is an algebraic, has this generalized algebraic form that all languages have. It's very general. Now, so if everything is code, language, and reality is finite, and everything is made of thought, which is finite, then it leads us to the fourth axiom, which was also published in, I believe, the Code Theoretic Axiom paper, and that's called the principle of efficient language. It's really simple. It simply says, if reality is made of thought in the mind of an emergent pan-consciousness computational substrate in the self-simulation hypothesis, and if it is finite, it means its resource, its consciousness, no matter how vast, is finite. And its goal seems to be to create as much of itself with as little of itself as possible, because that just means that you can become
conservationist.
Yeah, it means you could be a bigger consciousness over the same resource of finite thought or consciousness, and you can expand faster. So the principle of efficient language is very helpful, because for us at our scientific institute, it allows us to narrow down the mathematical possibilities and the computational simple programs that we speculate reality is built on. So the fifth axiom is also something that we already talked about, and that is the idea of retrocausality, or the guitar string, or the Ouroboros, the strange loop. And in our paper, we call it a strange loop. And that is
this would be the Hermetic principle of cause and effect.
You got it. Cause and effect between past and future, and that's it. So with those six axioms, we can get into justifying a little bit on why we picked this 8-dimensional crystal that's based on the largest accepted.
I had no idea that, I guess you've certainly never published this, that Hermetic principles played such a big role in how you guys at least constructed mentally the concept of the E8 lattice and emergence theory.
They did it. They indirectly. They may have subconsciously done, but unfortunately or fortunately, I didn't even know what the Hermetic principles were until a couple years ago, when I had that experience with Drunvalo 15 years ago. I just never bothered to get around to looking up who the heck Hermes was and what the Hermetic principles were, but I was encouraged and happy that older guys many years ago had kind of deduced that this idea that reality is made of thought, and then I saw, they were tuned into the same radio station, right? So this metaphor of tuning in is a big deal.
Yeah, we're definitely tuned into the same radio station, because literally all of my work, all of it, comes from that fountain.
Love it.
And I've published like 7 books now on like math. It's all new mathematics. I'll send you a copy of Philomath.
Love it.
My book, and it's basically the geometric unification of number, and basically all of our reality. And I'll definitely send you a copy of that. But the entire thesis of all of my work, and even my television show, I have a show called Code X on Gaia. And this year's, the second season, is called Metatron Revealed. And Metatron is just another name for Thoth.
Yes. Love it. Well, listen, so a little segue, in like the second or first year of this 15-year mission, my 10-year-old son claimed to be able to move his mind around like a ghost. Now, I was just coming off a lifetime of the materialist atheist thing, even though my reality was being shattered at that time, with a new paradigm. I had a hard time believing my son. His name is Haley. So I said,
"This is the son that I met. Is this the son that I met at
the son
party?"
You met.
Yeah.
And so he's a little older now. But Haley, I said, Haley, look, do you mind if I test you to see if it's real? And he says, okay. And I said, all right, good. Stay here. We were in a vacation rental in Turks and Caicos at that time. It was a big 4,000 or 5,000 foot house. So
Parrot
I,
Key?
huh? Yep.
Were you at Parrot Key?
Oh gosh, I don't remember. I just know it was
Beautiful
a
place. Yeah.
vacation rental called Stargazer
Hmm.
in Turks and Caicos, and it was such a cool property. So I go, I tell Haley, stay there. He was just sitting on a mat in a room, and I go to some other random part of the house and open the door to some bathroom, and I see on the right side of the bathroom sink an old basket of about 50 old pens, markers, pencils. So I just jab my hand in there, pull out a red marker randomly, stick it on the left side of the desk, close the door, walk way over to the other side of the house. Haley's sitting exactly where I left him. I said, all right, son, what did I just do? He closes his eyes and he says, you went into a bathroom somewhere on the other side of the house and you put a red marker on the left side of the sink. So I'm like, okay.
By the way, that's how they test Tibetan monks, Buddhist monks, on whether or not they're ready to go through the next levels of lama-ship.
Yeah.
They don't test them on their ability to predict the future. They test them on what happened in the past that they were not witness to and whether they could astral project their consciousness so that they could perceive it.
Yeah. So I still didn't believe it. And of course, after testing him, a dozen more times with different versions of that trick, then I became convinced that he actually did somehow leave his body like a ghost and was moving around the house. So then I said, all right, I want you to teach me how to do that. And this is where I started making shit up, Robert. So I had remembered the children's story from childhood of Peter Pan and how they would have their shadow body and they would pull it up. So I said, here's what we're going to do, Haley. And I was way too confident. I said, now, I'm going to sit here across from you while you leave your body, and I am going to raise up my mental arm, my imaginary spirit arm. I'm going to raise it up, right? So I'm starting to believe that this is real because I'm literally telling him what he has to do. Now, I need you to come float over my body like a ghost and grab my mental spirit arm and lift me out of my body so that you can take me around to fly around like a ghost. He says, that's very doable, no problem. So I'm sitting there with my eyes closed. I'm stretching out my imaginary arm with great strain, waiting for my kid to float above my head and pull me up like a ghost out of my body. So then it doesn't happen. But what I did feel is hard to explain. I felt a palpation under my right armpit as though somebody like poked me with their fingertip. And then I saw a light, like, how if you touch your eyeball lightly, it makes like a little light, like you can see a little light, like if you just touch your eyeball, right? So I kind of saw that in my mind's eye, but somehow superimposed over where in my armpit I felt that palpation. I didn't mention anything about it because I get, you get little muscle, palpation kind of feelings all the time. I mean, not all the time, but I didn't think anything of it. So then I open my eyes, I look across at him, and I blame him jokingly for not pulling me out of my body. I said, you didn't do it, Haley. What happened, man? And he says, Dada, I tried, but you were too heavy. So I improvised and I grabbed you under the right armpit and I tried to yank you up and you were still too heavy. I'm sorry. So then I realized, well, maybe that palpation I felt at that moment under my right armpit kind of was a little bit of a mind over matter telekinesis kind of effect. And long story short, since then, I've personally done remote viewing. I've done a little bit of mind over matter stuff less frequently. And I have seen it in peer review papers that I was surprised that were even out there from legit universities. I've seen it with many friends, family members. I have come to realize that I was flat out wrong about my Newtonian physics-based materialist atheist point of view, turns out that consciousness is apparently able to exist without being tethered necessarily to a human animal body because of that experience. So with the axioms, we now have this whole framework, and the one where I want to drill into is the principle of efficient language, because this, in some sense, is what makes the difference between what we work on, called emergence theory, which involves certain mathematics and computer theory stuff, versus the more agnostic cosmological framework of the self-simulation hypothesis, where you can plug in lots of different models and math and viewpoints. So it's all about bang for the buck. So mathematicians are always looking for a more compact equation to use less symbolism to explain the same thing. Computer coders in Silicon Valley can get paid $1 million a year if they are rock star compression algorithm writers. In other words, if you can figure out a way to write an algorithm in a computer code that takes less symbols than the former best algorithm, then you just save a lot of electricity for your boss, Google or whoever it is. So there's a lot of things, a double entendre in poetry, right? Just minimize the symbolism, maximize the meaning output. So this reality, because it's finite, because it wants to become more conscious, bigger conscious, more evolution, more experience with less symbolism. And this will be where I'll have to just ask your readers to give me, to just kind of say, okay, maybe, because it'll be hard for me to get into the mathematics very deeply of why the 8-dimensional crystal is the maximally powerful algebra that can describe spin and all of the facts of particle physics that we have. And then we have this other concept of the qubit. So this is a fun one because it's easy to explain, but it's super deep and foundational. So let's imagine a universe of all thought and a universe that's pixelated, like there is an irreducible letter, right? We traffic in English, and the irreducible symbol is one of these 26 letters, right? And you can get into bytes, which are 8 bits, but you can't get any lower than a bit in that type of code system. So what then, in a reality that follows the code theoretic axiom, everything is language or code, and follows the axiom everything's finite, and so you want to get down to reductionism of the simplest symbol. So, but this now becomes the simplest thought. What is the simplest thought that can be the letter level, proverbial letter of a universe of all thought? So for mathematicians, the simplest thought is the empty set. And when you get to thoughts like love, that's a complicated thought. It's definitely not a simple thought, right? And so we talked about EP and EC earlier. So no form of EC would qualify as the simplest possible thought. EP is always made of math thoughts, like your tic-tac-toe experience. So in the universe of math thoughts, the simplest thought is the empty set. And a set is just an abstract collection of thoughts or objects that can be mathematically defined. There's this type of set theory called Zermelo-Fraenkel set theory, which is more restrictive. And it says, oh, by the way, mathematicians claim that the ground of all mathematics is set theory. Okay, so this is why they would say that the simplest thought in mathematics is the empty set. Zermelo and Fraenkel came along with ZF set theory, and they said, we have a restrictive form of set theory where the elements or members of a set have to be numbers, and they can't just be any number, they have to be integers, like 1, 2, 3, 4.
Yep.
So I introduced a paper into the literature called Toward the Unification of Physics and Number Theory a few years ago, And we introduced formally a new form of integer called simplex integers. So a two simplex is an equilateral triangle, like that behind me in blue on my wall.
Yep. Mm-hmm.
And so it's a simplex integer, and it represents the counting number or integer 3 because it has 3 points.
Mm-hmm.
So a zero simplex is a point. And a point is a very simple thought. It has no substructure, no internal information, no dimension. It has very, very little of anything. It's a point. That's a one simplex. In ZF set theory, it can be seen as the set of one element, because now these simplex integers are formally adopted into the math literature as a new form of integer. And then obviously the empty set in ZF set theory using simplex integers would be the absence of the point. So you can think of the point being there, recognized or on, as one, the set of one element, and then you can switch hit as a bit, and you can say, no, now I don't see it, or I don't recognize it. It's not there. Now it's the empty set. So you modulate between the set of one element as the number 1, which is in the form of a point, because we want to work in geometry, and the empty set. The point is not there. It's off. So imagine that it would take a quantity of this precious resource of the finite universal consciousness to hold the choice. So the idea or the thought is a bit. That means, hey, I got to decide. Binary. I got to make a decision of on or off. But before I make the decision, it's going to cost me X amount of my consciousness to hold the decision, right? I have to understand the empty set as nothing. I have to understand the set of 1 as on, as a point, a zero simplex as a point, and I've not made the choice yet. So in order to make the choice, I have to hold the choice, right? And let's call the amount of consciousness that it takes to do that, let's just call it 1 or X. Okay. So in order to then make the choice, that takes more consciousness. In other words, if you say, Cle, come over to my house next weekend, and I'm going to give you a choice of chocolate or strawberry ice cream, you got to make a choice, but don't make it yet. Just hold the idea of the choice all week until the weekend. Now, then if I get to the weekend and I have to execute my choice, that's going to take X plus another amount of consciousness. So isn't it better for a universe concerned with the principle of efficient language to not make a choice until it has to make the choice? Because in that case, holding the choice of on or off, point on, point off, requires only X amount of consciousness. But once it makes the choice, it has to use X plus the extra amount of consciousness to make the choice. So this is a deep philosophical and axiomatic reason why in the heck reality would be based on the qubit. Because the only difference between a qubit and a bit is that with a qubit, you don't have to make the choice. You have 3 possible states. Choose it to be on, choose it to be off,
or both,
or don't make or live in an undecided state until you do it. But that's cheaper. Use less consciousness. So it's kind of cool how
isn't that kind of what our experience is, though? I mean, doesn't that also explain wave-particle duality in a way?
It does, and I'd love to say something about. So Carver Mead was a very famous physicist, and he was one of the first authors to describe what I think a lot of physicists today would agree on. And I think maybe your listeners would love hearing this, because it gets confusing when you hear wave-particle duality. Okay, the quantum mechanics says everything is information, and the information that we mean is a probability distribution, right? That if we knew the state of some particles in DNA or 2 electrons, whatever, we can then plug all that information into Schrodinger's quantum wave function and calculate it out, and it gives this spread of countless possibilities of how it could evolve over time, where all of the ways have a non-zero probability, but some have trillions of times higher probability than other ways. All right, in what case would it go from an abstract information-only wave of probabilities to something like a particle? The answer is never, right? It never goes to a particle. And the reason it can never go to a particle is because even in principle, we cannot measure down to the resolution of the Planck moment or the Planck volume. That is, in order for it to actually go to a probability of 100% that the particle is here at this XYZ coordinate at this exact time.
You're basically explaining the measurement problem in EPR.
That's right. It lenses. In other words, when you observe the particle to be hitting, so in the double slit experiment, we have a screen, and the screen has electronics that will allow you to detect where, right, on the screen, a particle like an electron hit it, that's fired from an electron gun. And then you have a timer like a clock, and that'll tell you when it hit. So the problem is when we see it hit, okay, the best resolution that mankind has is with an electron microscope. So that gives us a square area on the screen that is 10 to the 23 Planck lengths by 10 to the 23 Planck lengths. That is 10 with 23 zeros after it. We know it hit somewhere in that square angstrom, but science, technology, does not allow us to know where in that 10 to the 23 by 10 to the 23 Planck squares that it hit. You cannot know. So what happens is the quantum formalism, the quantum mechanics, says, oh, he has knowledge that it hit somewhere in this square, so it rewrites the wave function to say that it definitely did not hit over here, and over here, but we don't know where it hits here. So it lenses the probabilities from a very broad probability space to a narrower, but never to one specific coordinate where all the others are zero and that one is just 100%. And that means that very rigorously, no measurement has ever been done that can actually collapse it down to its particle state. It was in a wave state. It's a wave of probabilities in that example. And that's with an electron microscope, by the way. If you're just using your eyeballs, it's even a bigger spread of probabilities. And when it's in a spread of two or more probabilities, that's when we say it's in the wave form versus the particle form. So there never is a collapse of the wave function proper where it goes to the classical state and where one could say that, oh, now it's not just information in the probability spread, now it's somehow real physicalism. It actually never goes there. And even if we had better equipment, it still couldn't go there because there's something called, the uncertainty principle, which is a deep part of quantum mechanics.
Heisenberg.
Yeah, Heisenberg.
So I presented a slightly different but related theory to this in number theory. And one of the things that I discovered was that if you look at the reciprocal value for prime numbers, they have a unique characteristic that all of them have once you get above the number 5. So for every prime number above 5, their reciprocal values will always sum to a number that will sum to the number 9 in their periods. So for example, 1 over 7 is 0.142857. And those 6 digits repeat infinitely, right? 142857. If you add up 142857, it equals 27, and 2 plus 7 equals 9. So I discovered that in mod 9 analysis, every prime number has this characteristic in its reciprocal value. And of course, that characteristic has some significance because it's always represented in the form of a sine-cosine wave. So in the reciprocal value of the prime number, it has literally a sine-cosine relationship. The other thing I found was that for numbers that are semi-prime numbers that were made by multiplying two prime numbers together, you end up with the same phenomenon as long as the numbers that created those numbers were also, as prime numbers, greater than 3. So you could start with 5. So then I posited a new form of number called quasi-prime number that carried the characteristics. They were like the children of prime numbers, but not semi-prime numbers, because semi-prime could be divisible by 2 and 3. These are quasi-prime numbers that are divisible by only primes that are greater than 5, and they have this unique characteristic that their reciprocal period value also sums to 9.
Yeah.
So I created a table that then shows like a wave distribution of, you've got numbers that are highly composite, so divisible by lots of prime numbers, or lots of numbers, right? Doesn't have to be prime. And then highly non-composite. So these would be prime numbers. And I called the numbers because they happen to have a unique characteristic that we use them for all of our time measurements. So they're all in the base 12. So because they've got these unique, 12 has twice the number of factors than 10 does, for example. So 60 is the most highly composite number for its scale of number. 5,040 is a very highly composite number as well. And there's geometric relationships for all of these. So what I was able to show and put forward was the nature that every number has it in its reciprocal value, which of course is going to be related back to the Niels Bohr atom model, which basically shows that the relationship between hydrogen, its frequency, and its resonance characteristics in light are literally lambda and 1 over lambda, x and 1 over x, through its absorption versus its reflection relationships. So if you're looking at reflection spectra or absorption spectra of hydrogen, you would have this exact 1 over x relationship between the two. And many others, posit similar relationship for black hole, x and 1 over x, and many believe it's phi related, right? Because phi has this mantissa, its decimal extension, that's entirely identical to its reciprocal value.
Yeah.
Right? So, 1 minus, or phi minus 1 is equal to 1 over phi in the golden ratio. So what I found was that maybe, and posited forward, a notion that maybe what we consider wave-particle duality might actually be explained, that every number that's prime has a wave-particle duality aspect to it. One is its discrete observational value, and the other is its wave value. And until we observe it, it could be one or the other, because there's already something intrinsic to every number in its divisibility by 1, or divisibility into 1.
Yeah.
So this was a theory that I posited, put forward. You'll see it in my book. But it was a wave-particle duality relationship that also connects to Heisenberg's uncertainty principle, and also makes sense of kind of like the Bohr atom model, which I think, at least for hydrogen, was extremely successful in predicting the exact angstroms and nanometers of light that would be emitted by hydrogen, which is supposed to be our first light. I believe that they're hydrinos as well, but let's not go into that conversation. But I believe that that there might be some connection there.
I think that I agree with you. The genius of Nikola Tesla, right? People have different opinions of what he meant, but one of the deepest. This was a guy that contributed so much to modern, science, right? He's totally legit, but he had a lot of weird experiences, like I have had, and I think you have had, that could definitely provoke judgment from materialist, narrow people. But one of the things that he got from his, his altered states of consciousness, he was not altered by drugs. I'm saying he had episodes of these expanded states of non-ordinary consciousness, and he comes up with this deepness of 369, right?
Yeah.
And I think you know a lot more about that than I do, but I just will share. I have all kinds of notes and experiences from downloads, as I call them, that tie in, stuff like what you're talking about, but at a superficial level. So sometime in the future, Robert, me and you should get together.
I'd love it
to cross-pollinate, because perhaps some of your intuitions and your hard work can complete as missing puzzle pieces some of what we are working on here to make this theory ready for prime time, ready with evidence of a mathematical rigor that can start to open the minds of more, maybe more dogmatically convinced materialist type physicists. Because in a way, some of these peers of ours, the physicists, the materialist guys, in a way, some of them are gatekeepers of reality. In other words, until some of them admit, yeah, actually, it's mathematically rigorous, or yes, that experiment looks not, dishonest, right? Looks legit. So part of what we try to do at quantum gravity research is we try to straddle the line between being respectful of those people and not just judging them by blowing them off, because I'm empathetic to the rationale of why I was a materialist, atheist, person with a more narrow view. I was doing the best that I could do at the time with the knowledge and the experience and the peer-reviewed, papers that I had studied. I kind of was a sheep. I kind of just figured, it's probably a waste of time to do my own due diligence because I can't check everything out and I'm busy. So I'm just going to go with the rest of the herd and assume that all these claims of anomalous cognition and all these experiences are bullshit. And because these other guys who say that they're bullshit, they have advanced educations and professorships and they seem very smart. And then I realized that there are countless professors and rock stars, titans of physics, who actually have realizations just like ours, Robert. So
totally.
I was duped for a while, but I don't judge anybody else for being duped. I think people do the best that they can do. And quite frankly, I've met one physicist who admitted to me, my mother traumatized me and she believed in all of this supernatural stuff, and I recoil against it because of my terrible childhood. And so any physics theory, even if you show me evidence, I am going to be biased against it. He was honest, right? Because of my belief systems from my childhood. So some of them have that trauma that drives their dogmatic, in resistance. Other ones were just like me. I was always open-minded. I just felt like I was taking the path of least resistance to join the herd of the materialist, dogma.
Well, and thank you.
Yeah.
But thank you for doing what you're doing, because I think that's been part of the chasm that's been between the two worlds. I'm similar to you in this way, where I see myself as someone who bridges worlds, I get invited to speak at United Nations, and I get invited. I'm going to the Vatican again in a few weeks. I'm getting knighted by Portugal and Italy.
Ooh, nice one.
And I got knighted by Montenegro last year. So I can be in both worlds.
Yeah.
As business people, we're kind of afforded this right, because we're willing often enough probably to pay the ticket of that, whatever that ticket is.
And as entrepreneurial, as serial entrepreneurs, maybe guys like you and me have a nice balance between creativity, because we literally invent new ways of doing product business and service, but we also have to be pretty down to earth and grounded to deal with the bankers and the CFOs that we hire and so on.
Yeah, that's right. Yeah, we can't just entirely get our freak on.
Yeah.
It's like it's not going to fly. But I think in coming towards the conclusion of this, I think a couple things are coming to mind that I'm getting prompted to share with you.
Okay.
One of them is you're talking about compression, right? Compression of data. I have close to 100 patents on all kinds of stuff across electromagnetism, laser technology. I spent much of my career in photonics before I went into the pharma world even. So I was always fascinated by it. So I've got quite a lot of intellectual property in that space. And basically, let's see if I can pull this up here for you.
You know what Kolmogorov complexity is then, right?
Yeah. Uh-huh.
Yeah, that's a big part of emergence theory is compression.
Yep. So I filed a patent on this some time ago and posited that the most efficient compression is geometry of right triangles itself.
Yeah.
Because all it requires is, you pointed out already, is 3 points. It doesn't even, in fact, you could get away with only 2 points because the nice thing about triangles is that once you have two sides, the third side's already implied.
Mm-hmm.
And what I basically filed a patent on was being able to utilize, because you could figure out that if you had like two sides that would be rational values and one side that's irrational, the one side that's irrational could end up being an infinitely long number that could be a storage house for a lot of data, right? So all you do is have to give 2 points of reference, right? And then you solve the metrology issue, which can be solved through trigonometry. And then you could end up with a compression that is extremely efficient. And you compress all the data inside of these 2 points of reference. You have a central point that would form the 90-degree angle that you use every time. And then the distance between the two as a reference point becomes, the third side becomes the value that you've basically taken for your compression, or the side inside the square root value that is the height. It's related here. Yeah. So square roots, you could say that the square root of 2 is like the essence of the number 2, and it's infinite.
Exactly.
And this is why I started making infinite, super huge calculators to do things like prime factorization, right?
Yes. And you can
see,
Robert, how this principle of compression relates to what we talked about on the principle of efficient language. In other words, compression is just saying, hey, I want my cake and eat it too. I want to represent this meaning, but I want to figure out how to use a lighter symbolic load. So ergo, I need to compress.
Yep, exactly right. So the nice thing about this too is, just like in the show, it's funny because I made this before I even watched the TV show. The TV show that's called Foundation. That was Isaac Asimov's story,
good,
right?
Like a cinematic TV show.
Yeah, absolutely. And so they put all of the information for their civilization before they went into this downstage, right, of consciousness and got destroyed. Harry Sheldon, the mathematician, the spiritual mathematician, ends up putting all of it, right, into the cube octahedron, right? And what's nice about the right triangle is the right triangle can fill any void space, and it doesn't matter what that void space is, right? So it can basically occupy all of it. So basically, that's what this posits, is that you could store in one geometric form infinite amount of data just using these same vector points.
Wow, yeah. Let me take the screen and try to support what you're saying to connect it to something interesting in emergence theory. So I will, share. Okay, here we go. All right, so let's go to this image here. All right, so you see up here on the left side of the screen? Does my mouse move on your screen?
Yeah, I see it. Yep.
All right. So this right here is so you see how this is a cube octahedron?
Yep.
Up here on the upper left in yellow, that forms the 12 vertices of a cube octahedron. But what we did is we put a point at the center of the cube octahedron inside of the volume, and then we just draw lines from all the 12 vertices. We just draw a line straight down to the center. Boom, boom, right? And then we group these into groups of 3. And so we get this is called a convex hull, right? The surface, the points on the outside is literally just a cube octahedron, but we make it a little more complicated because we put a point at the center. So there's a 4-dimensional version of the cube octahedron, and it's called the 24 cell. And the 24 cell, for your viewers, looks like this.
Yep.
Okay, over here on the right, this is, you can't really easily visualize it because we live in 3D, not 4 spatial dimensions. But if we did live in 4 spatial dimensions, it would look kind of like a cuboctahedron, but instead of having 12,
It's like a tesseract version of a cuboctahedron.
Exactly. It's the tesseract version of a cuboctahedron. And so anyway, so now what we do is we are talking about compression. So what we do at quantum gravity research is we take
one question. Have you looked to see what's the connection then between the 24 cell and E8 lattice?
So the E8. So I would love to answer that. So to answer that, I just need to introduce a couple terms here for us, and us being your audience, me and you. And so the first one is I want to introduce a fancy term called a root vector polytope. And in order to do that, I'm going to make it in a simple case called the A2 lattice hexagon. So this, I'm going to show a picture of the A2. So algebras called Lie algebras, they have this this thing called a root lattice, and they can be in various dimensions. And I'm just trying to bring one up on the screen. All right, here we go. So you see this on the right side?
Yep, I sure do.
So this is the root lattice for the A2 Lie algebra, and it's obviously in 2 dimensions. So you can see it's just like a tiling. Ignore the hexagons in the back. Ignore the gray lines. Just look at the black lines. And so we see that if we randomly pick any vertex in this lattice, then we find that that vertex radiates out 6 lines of the same length, just like this. And those 6 lines form a hexagon with 1/7 point at the center. So that is what we call the root vector polytope that defines the entire lattice. In other words, if you just know this hexagon segmented by the 6 triangles, then that's all you need to know for the infinite A2 crystal or lattice. So the 24 cell is the root polytope for a 4-dimensional crystal called the D4 lattice. And it turns out wonderfully that we can construct the root polytope for, which is just the shape, the root shape. We can construct that fundamental root shape of the 8-dimensional lattice, which is the lattice associated with what mathematicians call the largest exceptional Lie group, very, very important for physics. That whole lattice can be described by this one 8-dimensional shape called the Gaussian polytope. And it has 240 vertices. And it can be made with 10 24 cells. So
that's what I thought.
Let's take the Star of David. It's just a triangle, and then you just make a copy and flip the copy, right? And then now you've got 2 triangles, one flipped from the other, and that forms this symbol called the Star of David. So that is a compound. In other words, the Star of David is a compound made from 2 just 2 regular triangles. Similarly, this 8-dimensional shape that's so important is a compound of 10 instances of the 24 cell that all share the same center point. Okay, so each of the 24 cells, by the principle of compression or the principle of compactification, we project them down to a lower dimension. And when we project them down to the lower dimension, they become what's mathematically called quasi-crystals. So quasi-crystals are just shadows of projections of higher dimensional crystals. So if you could live in 8D, like right now, your camera or a camera on the top of my computer is looking at me with one eye, one lens. I am 3-dimensional, right? But what it does is it smashes my 3-dimensional visage down into a National Geographic flat photo. But your mind has algorithms that is taking these flat images of me, and you're deducing the meaning of depth and that my head is hot.
Which is another form of compression.
It's another form of compression. So quasicrystals, in other words, are a form of compression to use lower symbolic loads to describe the mathematical geometric meaning. And so, as I showed you up,
if I took this, for example, and I had a shadow cast on my desk from a light above it, light source above it, it would form the flat shape of a hexagon.
And
so
and
all of the information necessary in that is already there.
That's it. And then
even though there's a lot more information in this.
Thank you. And then if you take the 24 cells that live in the compound of 10 of them, 10 24 cells make the 8-dimensional polytope or shape for this most important part of our model. And so if we simply project a shadow of each of those 24 cells down to our humble 3 dimensions, 5 dimensions lower, we go from 8 down to 3. And then what we have is, and I think you're seeing my screen again now, yes?
Yep, I am. Mm-hmm.
So what we have is up on the upper left, that is the 24 cell, but it's represented by this trigonometry that projects it from 8D to 3D. So what this is 5 24 cells. And then if I showed you the superposition of the right-handed and the left-handed 20 group, in other words, this is 1, the red one and the orange one is 2, so that's a compound of 2, and then that's 3, and then this is 5. So this is basically just a compound of 5 of these. Each of these is a 24 cell. And then if I show you the right plus the left one, which might have an image of that, but I think I'll not slow you down to show you. So that then the compound of 10 of these 4 groups, I call that a 4 group because it's 4 tetrahedra, having the convex hull of a cuboctahedron and being the projective representation of a 24 cell. So that's 10 of them in the compound that is the right and left superposition. And that represents this 8-dimensional shape. And where these edges cross, the red edge and the orange and the yellow edge, where they cross, it divides that edge by the golden ratio, not approximately, precisely. And so the golden ratio is required in order to rotate these projections of 24 cells from one another in order to close the gap that would exist between their faces if you didn't do the proper rotation. And when the gap closes, it can be one and only one rotation, and that is the rotation of a golden ratio based angle that also subdivides the edges by the golden ratio.
Okay, so I knew there was a reason we were supposed to meet, and why I keep getting all this stuff on physics the last few weeks, even though I've kind of stopped doing a lot of my research in physics over the last few years. But all of a sudden, the week before I meet you, I'm getting like crazy in the middle of the night downloads, which never is coincidental, like never.
No.
So I published this paper. You should be able to see this. And it's called The Accurate and Infinite Prime Prediction from Novel Quasi-Prime Analytical Methodology. So I posited a new type of number, which is what I explained to you, which is numbers that are not divisible by 2 and 3, but they have other characteristics like semi-primes, but they're closer to primes because they have this reciprocal value that sums to 9 in its period.
Yeah.
Okay. So basically, the paper has at the end this chart which shows a mod 24. So what I realized in part of the paper was I proved that every prime number after, from 5 onward is related to the number 24. This goes directly to your 24 cell, and I'll explain how in a moment. So this might be what you're looking for. So every prime number from 5 onward, when you square it, will always be a multiple of 24 plus 1 in mod 24 analysis. So it'll always end up in the mod 1, which is the one with the yellows in it. All the other wheel spokes here don't have yellow, right? Yellow is the prime squared. So you have 5 times 5 is 25. That's 1 times 24 plus 1. 7 times 7 is 49, and that's 2 times 24 plus 1. 11 times 11 is 121, that's 5 times 24 plus 1. And 13 times 13, the next prime number is 169, that's 7 times 24 plus 1. This pattern continues on infinitely. Now, what is the 24ness and what's the importance of the 24ness? Well, it allows the four polarities posited by Walter Russell and by Nikola Tesla to be able to show their fullest expression. So when most people, we're such reductionists, we want to think about, okay, every prime number is a multiple of 6 plus or minus 1, right? And that is true. But you can't see the full expression of it until you can see it in quaternity. And that's what this is. So basically what you're looking at here is a two-dimensional flattened form of the 24 edges of a cuboctahedron.
Wow.
Okay, so this 24 mod 24, and all the blue numbers are what I would call time numbers, and all the red numbers are prime numbers. All the green numbers are quasi-prime numbers. And all of the semi-prime numbers show up in black. The ones that are divisible by 2 and 3, they're automatically excluded from this. So from this, I was able to create a new algorithm to predict primeness infinitely and prove it.
Can it predict, but it can't predict the quantity of primes within an arbitrary bound of the number line, can it?
No, but I discovered another method to do that, and it's not the natural log. So the natural log, that's the norm, that's the way you're thinking of, right?
Yeah.
The other method that I found to do that is that it actually begins. So here's, I'll just have to explain a little bit on this. So the number of prime numbers that show up within any given number set is supposed to be tied to the natural logarithm, right? Which is the Euler number. Okay. So in the first 1,000 integers, how many primes are there? There's 168. But the number of prime numbers that show up using the natural log to define it only gives us 144.7. Why the delta? That's a big delta. 144 to 168, that's a big delta. It's 24 number difference, right? So then I started looking at it a little differently. So I looked at it not only from that context, but I looked at it from the first 100 integers. So from the first 100 integers, the natural log would imply there's only 21.7 prime numbers, when actually there's 25. And then there's the question if 1 is prime or not. Well, I tend to believe that 1 is actually prime, because how could it not be prime? But that's a whole nother discussion. So what I found is that there's an asymptote for the distribution of prime numbers. It doesn't start with the Euler number. It ends at the Euler number. It starts at the square root of 10. The square root of 10 becomes the actual value. So if I use the square root of 10 in the first, set of numbers that go all the way up to 10 to the 10th power, and if I want to predict the number of prime numbers within any given number set, if I use the natural log, instead of the natural log, I use the square root of 10, which is 3.162277766, then it gives me a far more accurate number to tell you the exact number of primes within that given number set.
So this implies that there's something fundamental about base 10. And I know you're talking about the square root of 10, but it's certainly making 10 special. Robert, I would be open to exploring doing a paper with you, and we would need a PhD mathematician maybe to help us, a number theorist. But I have this paper I just emailed you called Toward the Unification of Physics and Number Theory, but it might be better titled Toward the Unification of Geometry and Number Theory.
Yeah.
And I'd like to just geek out, and I know we're coming to the end of our time, but I'd love to invite you in front of your audience to riff with me some point. Probably ask you to just do one homework assignment, which is to kind of read that paper and then tell me.
I will.
Tell me what what I can answer about it. But anyway, but I want to tee up your audience and you with a tantalizing question or realization. So now that we have formally introduced into the math literature simplex integers, you can ask the same question. You can say, within the bound of the one, the simplex for the integer 1 and the simplex for the integer 100, how many prime simplexes are there? Well, we know the answer. It's exactly 23, right? And we know that the most popular algorithm for predicting that using number theory would give us a grotesquely wrong number. Now, I want to introduce. I might be off on the 23, but whatever it is, it's very easily countable, just like you can count the primes by hand, but between 1 and 10. But the point is the prime number theorem gives you always a wrong number. Now, I want to introduce something that'll be very hand wavy, because there's no way I can explain it to the audience really here, but I can at least make claims. So at the root of all of the proofs in mathematics, the number one assumption undergirding so many proofs is that something called the Riemann hypothesis is true.
Oh yeah.
Yeah. So the Riemann
non-trivial line, 0.5.
And the way to hand wave but dumb down what the Riemann hypothesis means to some of your viewers is thusly. The Riemann hypothesis is an important hypothesis supporting so many proofs in math. It's believed to be true by most mathematicians. But what it is deeply about is about the inaccuracy of the prime number counting theorem. The prime number counting theorem just says, hey, let me take the trillionth integer, like the number 1 trillion, and then go to 2 trillion. Now, between that bound, there's a trillion just integers, right? And this algorithm, the prime number counting algorithm, is a way to say, all right, here's the bound, 1 trillion to 2 trillion. Now you tell me, algorithm, how many primes live in that bound? And each and every time the algorithm is wrong, but it's the best mathematicians have. The wrongness of the algorithm is apparently very, very deep. In other words, we don't know what the right algorithm is, but we know that the delta between the mysterious correct algorithm and this wrong algorithm is very rich. That is important. And so the idea of the non-trivial zeros and the proving of the Riemann hypothesis is essentially deeply about the wrongness of the prime number theorem, which is that algorithm. So now I'm going to do the punchline to this setup. If I give you a simplex integer, that is, I give you the simplex integer for the number 1, which is a point, and the simplex integer for the number 10, which is an equidistant array of 10 points in 9-dimensional space. If I say, well, how many prime simplexes are in there? Well, you already know the answer because it's such a small number. It's 1, right? 3. It's like 1, 3, 5, 7, right? That's it.
Yep.
Now, when you ask the question, how many prime subsimplexes, because any simplex like an equilateral triangle is made of subsimplexes. So how many subsimplexes are prime, and the prime simplex is the same as a prime integer. It's like the quantity of the vertices, the little points.
Right.
It has to be divisible only by 1 and itself to be a prime simplex. So anyway, but the point that I'm making is that it is no longer a statistical question, the way number theorists deal with vast supercomputers and probabilities and algorithms like the prime number counting theorem. It's no longer in that regime. Now it's in the regime of pure geometry, trivially so, because you're just looking at a shape and you're asking, well, how many subprime simplexes does it have? It's a very geometric problem. And when you read this paper, I will give you, and for your audience, I think I already said it can be Googled. It's open sourced and published in a physics or math paper. It's called Toward the Unification of Physics and Number Theory. But I think you'll enjoy reading it because I didn't realize how interested you are in number theory, right? Prime number theory for listeners is about primes and the distribution and how do you predict, how many primes. But maybe if you read it, you'll come up with a deep thought that could lead to a possible collaboration where we cross-pollinate, our ideas.
Oh, absolutely. I would love that. I would totally love that. And you're exactly right, because it's funny. Our intuition had brought us to the same point, which is that there's fundamentally, and I think it comes down to actually a true and correct explanation for a real value for what we call the imaginary number or the complex plane.
Yeah.
And it's the square root of 10.
Yeah.
And the square root of 10 to the power of -1. So it's a function that we call fractal rooting. We actually wrote a paper on it. I'll send it to you.
Yeah.
The fractal root of numbers. And so you take the square root of 10 and then the square root of 10 to the power of -1, which is its reciprocal value, ends up creating a negative polarity. Whenever you switch between orders of magnitude, there's a slight negative charge that picks up on the number. So it becomes 3.162277766, and the square root of 10 has this one unique characteristic no other number does, not even the golden ratio. And that's why we know fundamentally that base 10 has a fundamental aspect. And that is that it retains the exact same numerical value. It just shifts one decimal position.
Yeah.
So the square root of 10 taken to its -1 power ends up becoming negative, right? From a polarity, it's a different way of looking at this, -0.316227766. So it's identical number. You multiply those two numbers together and they equal -1. And that is where, so really the beginning of the distribution of prime numbers is from the value, the real value of I in the imaginary or complex plane of numbers. And that's where the beginning of the asymptote starts. And then it ends with each irrational, transcendental, irrational extra digit added to the Euler number. That's why Euler becomes extremely accurate as you get far, far, far out of the number series for using the natural log to predict the number of primes. It is not at all accurate for the first 10 to the 12th power numbers. And it's because it's an asymptote that begins at this value for I.
So I love that, and I'm so happy that you're open to collaborating. So Robert, one last thing that I can't resist is a further connection of counting numbers, integers, to geometry. So a lot of our listeners have graduated high school, and we learn as small children in elementary school the geometry of the integers, 1, 2, 3, 4, 5, the integers, right? Because we call it the real number line, right? And so it's just a line with evenly spaced points on the line, and then we just decorate that with numbers. But that is not actually just a metaphor that it's a number line. Integers are the first of the 4 division algebras. So the 4 division algebras are the integers, 1, 2, 3, 4, the complex numbers that some of us learn in high school, and then the 4-dimensional version of the complex numbers called the quaternions, right? So you have quaternion integers, and then the end of the party, the end of the road, which is the 8-dimensional integers called the octonions. But for each of those number systems, you can composite them from the lower dimensional ones. In other words, you can build the complex numbers with lattices of the 1-dimensional number line. And in that case, you have, because I only focus on the integers. So on the complex plane, I have these integers that are, I have all these integers, and they're made of an imaginary integer, and they're made of a real integer, and that tells me what it is. But because it's a plane, you can see, oh, maybe it really is not just a metaphor. These numbers are geometric. And as we go to the quaternions, they too are geometric. They're in a regular 4-dimensional space. And so when I talk about the crystal, which is an 8-dimensional point set that we talked about its root polytope being this 240 points that's equivalent to a compound of 10 instances of the 24 cell. These are all numbers, but numbers, these 4 classes of numbers are geometric numbers, even though most people don't really think that through because they learn, oh yeah, the complex numbers are obviously geometric. The real numbers, I guess the real number line is geometric. Then the quaternions and octonions are the 4 and 8 dimensional. So these 4 dimensions are interesting, and to explain why it ends, why the party ends at 8 is way too complicated and hard to explain just with English here. But that's the basis of emergence theory, is we are using the interaction of these like gears. We're using the cycles of how these 4 different geometric number systems of integers play into each other. And there happen to be complex prime numbers, quaternionic prime numbers, and octonionic primes. So the idea of primes is so, and the last thing I'll say, and a lot of this, obviously, Robert, is not for you. I'm just saying to be a good guest and share nuggets with your audience. But the importance of primes, one might say, well, who cares? Why are Robert and Cle talking about primes? Well, primes, everyone, are the essence, right? The skeleton, the core of these important numbers for physics and life, which are the counting numbers, right? That how many of a thing do I have? And the core of them is the primes, the irreducible. We call them the atoms, as the proverbial, because the word atom in Greek means indivisible, but now we know atoms are divisible, right? But the idea of the irreducible building block of any large number is these atoms of the number system, which are the primes. They're very beautiful, very deep, and each one has its own personality and deep structure. And when you understand shape primes or shape integers in the form of simplex integers, then it gets really rich, because now you see the depth of numbers in the form of geometry, where you get dihedral angles and volumes and ratios of volume to area. Robert told me about the most fascinating thing today, that he told me a triangle, a right triangle that has edge lengths of 12, 13, and 5. Well, obviously 12, 13, and 5 adds up to 30. So the area of the perimeter of that triangle is simply 30. But remarkably, the area of the triangle is exactly 30. And I don't think that there's any other known right triangle, much less right triangle.
There's only one that does it, and it's not reduced. So if you take a 3, 4, 5 and you double it, so that it would be a 6, 8, 10. It'll have the same characteristics, but it's not a Pythagorean triple because it has to be reduced to the common denominator.
It's like a prime concept. It's like that first one at 12, 13, 5 is irreducible. And then you could build an infinity of ones that are made of that. So which is
so funny you bring this up, Cle, because this is beyond synchronicity now. So I'm going to show you something that I think is the last things I'm going to leave as parting, I guess, things to you that I think point to us definitely working together. So here we go. Now, if you take this concept of using the square root of 10, right, or the fractal root of 10 to describe the Euler's identity, which is supposed to be the most beautiful equation in all of mathematics, this is how you do it. So you basically take the square root of 10, right? And to the power of -1 just means it's reciprocal. So then, according to Euler's definition himself, right? Euler's definition of this, n to the -1 equals -n. This is part of the definitions by Euler himself. So the square root of 10 to the -1 times pi, to start actually working this equation, right, equals -0.99345 and on, right? Now, what I've noticed is that there's actually a decimal when you're working with Euler and pi. Euler is a number set that works across dimensions. So this working across dimensions means that it has to be converted into sexagesimal math. So you make a sexagesimal math conversion, which I don't know why this is, but I'm telling you it works, which is bizarre. So then you take this value of the negative 0.99345, and that will give you a value of, when you make the sexagesimal conversion, it comes out to, this 0.37036, right? Which then, if you then take that value and use e to the I pi plus 1, it gives you 1.37036.
Huh.
So e to the I pi plus 1 doesn't equal 0. It equals light.
Huh.
This is the fine structure.
Yeah, I know. Something deep
It's
about
7 decimal digits accurate. 7 decimal digits accurate to the fine structure's reciprocal value.
Remember at the New Year's party, Robert, we were talking about the reciprocals of the single digit integers and how 7 is the oddball. In other words, you got 3, 6, 9, which make these really pretty inversions. When you divide into 1, that's just like all 3s or all 1s or whatever. But and then you've got the ones that just go to like 0.4, single. And then the oddball is just 1 divided by 7, and that's the only one that just has this repeating of these 5 digits. 1, 4, 2, whatever. So there's something
14285. Yep.
Yeah, something as a little bit of an oddball with.
It's kind of like that's the number that gives us electromagnetism and gravity, and I can explain that when we meet.
Yeah,
but it's literally electromagnetism and gravity.
Well, also the group theory in the standard model of particle physics for electromagnetism relates to what I showed you earlier, where you take a hexagon and you put a 7th point at the center, and then you draw the extra lines for the 6 roots, but you need 7 points to do that. And so that's a super important value for particle physicists. This hexagon, not just a hexagon segmented by 6 equilateral triangles, which means you have to have the 7th point at the centroid.
Yep. So are you familiar with this whole, divergent series of numbers analysis on the number theory part that was done by Ramanujan, which is that if you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 infinitely, all numbers, somehow it comes back like an Ouroboros into some finite value?
Oh, no, I should look that up. But I know that Ramanujan was probably accessing anomalous states of consciousness in the non-local field, because that guy got some really important stuff. Well, one thing we need for our mission, which is he figured out a Fourier analysis called the Ramanujan Fourier transform, which kind of translates between the world of wave-like, geometry and math and non-wave systems. It's very important. But what is the Ramanujan Fourier transform? Well, if you had a system of numbers based on the powers of the golden ratio power series, that is, if you have numbers like we use in our quasi-crystal mathematics, well, then if you're going to do a Fourier transform, then you want to use the bespoke, custom-made one for golden ratio, which is the Ramanujan Fourier transform. How this guy thought of these things, he always said it was credited to some kind of spiritual entity.
It was spiritual, yeah.
And I believe him, but maybe I need to also look at this work of Ramanujan that you're.
Yeah, you can find Numberphile does a nice synopsis of this. It's a big controversy in mathematics, right? How can an infinite series of numbers add to a finite value?
Right.
And yet it does, and it's actually a pretty simple algebraic exercise. So I started looking at this, and I started saying, okay, clearly there must be some form where infinity envelops back into itself, just like a Klein bottle, or some form of a Mobius strip that actually inverts itself and goes from infinite back into finite and then back and forth.
Yeah.
Right? So this is, so then if that's true, then you can apply ratios of these values to each other to see if they make geometric forms. And as far as I know, no one had done this before. So I looked at the regularized product, which is the infinite factorial. So instead of 1 plus 2 plus 3 plus 4 plus 5, it's 1 times 2 times 3 times 4 times 5 times 6 and infinitely. And it gives you the square root of 2 pi or tau, right? So knowing the work that I had done to look to see, is there a relationship between, in geometry, the sum and the product? And I wrote a paper called the sum product conjecture and proved that the sum and product is created from a right triangle, all of it. It's not even, it's something that was quite easy to prove. So from that, I was able to take this into another kind of analysis, because you can tell most of my work has been in right triangles, right? It's all in right triangles. And the right triangles have informed a lot for me, and that the solution to all of this comes back to this.
I'm looking at a bunch of right triangles behind your left ear there on the monitor. The dark and the light side of that wood is just 2 right triangles on the dresser right behind you.
Oh, of course. Yeah, absolutely. No, it looks like the lattice that you were just showing.
Yeah.
So interestingly, the shape, right? And what you learn from this is what I came to, is this, which is that you have the sum, the product, and the difference of 2 numbers. Remember, I was explaining that in order to form the height of the triangle, which is a geometric mean value of 2 numbers, x and y, in order to form the hypotenuse, which is the arithmetic mean value of 2 numbers, x and y, and we've never thought of it in this way, to think what would be the forces behind these numbers to create the right triangles. Nobody questions that right triangle is the foundation of pretty much everything, because it's exactly what the inverse square law is, right? And we could go on and on and on about this. And so what I posited was that this is the way thought works, that you've got ratio, which ratio is giving us relationship to reality. So even though we don't have reality, if you can pile a lot of ratios to have perspective for our perception, so that you'd have different perceptions of different things. If I don't know how big something is, if I could ascribe some value to it without having to ascribe a number to it, but compared to something else, right? Whatever the compared to something else is, this is the notion of dimensionless, right? So pi is dimensionless. Euler is dimensionless. Alpha is also dimensionless. So we have this smoke and mirrors, video world that we ascribe scale and size to based on our familiarity and based on the size it is compared to other things.
Yeah.
So this becomes like a realm of forms.
Yeah.
And that's a first dimension. Then the second dimension is when we start to ascribe those realm of forms into some thought that's formalized. It could be that you're making it into a piece of art. And then you give it depth, and all of it still is based on right triangles. Then you give it depth, and then it starts to get resonance and motion. So now we're in the 4th dimension. Well, then you've got an explanation how everything comes back to prime factorization.
Yeah.
Like literally everything comes back to prime factorization. So, and this is where we'll basically show you one last thing, and then we'll continue this conversation. We could do it, in front of other people or not. I'm sure our followers would probably love to have us do it in front of other people, but we may not. But the point is that when you make a triangle of the scale of those infinite values, guess what triangle it makes?
What?
This one, which was left to us by Leonardo da Vinci in his square and circle that are not of the same size. His square has an area of Euler 200 years before Euler number was discovered. And his circle with a radius value of 1 has a value of pi.
Oh, wow.
Because you can't see it?
No.
Oh, you're not seeing it. Okay, I'm seeing it. Let's see if I can stop it and try it again. Do you see it now?
Oh, is this the one you showed me earlier before we started?
It is. It's the same proportion. This has been hidden into esoteric wisdom and knowledge by Michael Meyer, by Leonardo da Vinci. He encrypted it into this. And so the exact form becomes the infinite sum, turns out to be 1 over 24, right, as a right triangle. The other one, the other side down here becomes the square root of tau, right? And then, which is the fourth root of tau, excuse me. And then the other one here becomes the difference. So guess what proportion you have? A 5, 12, 13 triangle.
Huh. Yeah.
You've got the same 5, 12, 13 triangle, and it's defining for us the infinite sum, the infinite product, and the infinite delta.
Yeah. Yeah.
To me, it said something about wisdom. It's like the infinite sum is like omnipotence. The infinite product would be omnipresence, and the infinite delta is like the wisdom to know the difference.
Yeah.
And it's embedded in Leonardo da Vinci's work. So, of course, this is why I started looking at this. I was like, why would he encrypt? Because the way you would encrypt this triangle is to draw a circle and square with the same base. That would, all you'd have to do is connect to the top of the circle and connect to the base of the square, and you finish the triangle.
Yeah.
This particular triangle is something really, really fundamental. I don't know exactly yet. All I can tell you is it matches perfectly these proportions, which is just like beyond bizarre. And what this also does is this describes, and this is what I just got in this week, and no one else has even seen this yet. All right. So there's a geometric relationship between the quadratic mean, which is equivalent to energy and 1 over time. The geometric mean of these two numbers, right? That could be anything because it's going to be based on the mass. But then, however, the vector gets shifted, defines from these right triangles. So you've got C, which is a fixed value here, and the gravitational constant is basically also 1 over the speed of light times 2. The radiation is 1 over dark divided by 2. And when I say dark, it's graviton. So this line, because with right triangles, you may know that you can flip the sides of a right triangle and maintain the values and maintain their proportion by turning them into reciprocal values. So it literally acts like an anti-proton, anti-electron kind of inverted mirror pairing. The right triangle can create left triangles. Let's put it that way.
Yeah.
The right triangle has 3 left triangles.
Right.
And we wrote a paper on this too. So effectively, this line becomes 1 over mass. This becomes C and gravity. And this becomes energy and time in its reciprocal forms. And it's as simple as geometric mean, arithmetic mean, and quadratic mean. And it goes backwards to harmonic mean as well.
Yeah. Very, very, very.
Of 2 numbers.
Yeah. Wow. That's see, I don't think you could just find those circuitous paths of discovery without a little cheating from anomalous states of consciousness. In other words, there's luck, there's just hard work and brute force, but there's also that X factor where it seems like you listen to your inner intuition as you travel down these pathways, because otherwise you wouldn't be able to discover so much surprising stuff in one lifetime.
Well, I think what you guys have found with the 1024 cell,
yeah,
the proportion of that is embedded perfectly into that same triangle.
Yeah.
Because the proportion is 10, 24, 26.
Yeah.
The 5, 12, 13, that's why you got triggered by it right away. You're like, oh, that's interesting triangle. And you brought it back up at the end. Because that triangle is the second dimensional representation or compression of the 1024 cell or the E8 lattice.
Yeah, I think you're right. And for us, we see all the fundamental particles, that is the massive fundamental particles such as neutrinos, and electrons, positrons, we see these quarks, we see these as something we call cycle clocks, which is where you go through cyclic permutations of flow patterns that come back to closure with things like that 24 cell 10 compound in 8D that is represented in our reality by the 10 compound in 3D that I showed you. But there's various cycle paths on how you can cycle back to closure over and over. And those different ways of doing that would define the different fundamental massive particles. And then the photons or the bosons, which are particles that don't have mass, then those are effectively like the ripple patterns around the structures that we understand in our group as these patterns in the quasi-crystal math that you can only analyze at with large enough numbers, right? As you zoom in just to points or 2 points, you don't have enough information to see the emergent wave-like stuff. But very, very fascinating and enriching conversation today, Robert. Thank you so much.
I'm looking forward to. Let me know when you can meet up. I'm more than happy to come up to see you guys, and I think it'd be really exciting. And I've been wondering why I've been getting this physics stuff lately, the last 3 weeks or so, and in particular this last week.
Yeah.
And now I know why. So I have a feeling that I'm going to end up sharing all of this stuff with you. And
my favorite thing for starters with you is to see what your thoughts are on the other side of that paper that you're going to read about number theory, but tackling it for once through geometry. As you know, Ulam's spiral, he was just messing around. Totally. But he discovered that there's a still unknown reason. They still don't know why. Like, why did that pattern show up in Ulam's spiral? He was just playing around. But to this day, you could go to UCLA, where Terence Tao is, the world's best number theorist, and they're all still ignoring geometry and using the same brute force of statistical analysis, and it's not getting them anywhere. And so I think to attack the problem for mathematicians in the future, because this is 2,000 years that they've been working on this problem, right?
Yeah.
And so I think it's a dead end. And I think that the pathway out to solve it is to understand it through the lens of geometry. And you just instinctively think in geometry. As you think of number, you're thinking of geometry. But let me know what you think about that, because it's either going to trigger some completions.
Yeah, I'll read it tonight. Definitely.
All right. Yeah, and then we'll talk next. And like I said, I think between you and me putting in our intuitive guidance from our downloads and our many years of thinking about this, and then we partner up with some kind of number theorist or someone that we can find.
I have a really good number theorist.
Really?
Actually, I have a few.
Okay, That's perfect. So, all right, Robert, I'm so excited about that, and I appreciate you exposing me to your wonderful audience. And
thank you. Keep going with what you're doing. It's very exciting. I think, as a conclusion point, I think the world thinks that by studying more physics or studying more mathematics and going down the same ways and paths of doing things we've done, that we'll be able to advance the field more. And what I would put forward to you is the truth is probably the exact opposite, which is it's only through, I believe, the doorway of raising our frequency and increasing our vibration that we can access these higher states of awareness that allow us into these different areas. And it's only through polymathic thought that we're able to do that. This is why all the mathematicians who discovered math were also music theorists.
What's a quadrivium thing?
Quadrivium, exactly. Yep, and we just finished developing a quadrivium calculator, which is the first of its kind. I'll show that to you when I see you next time.
That's fun.
And it's super epic. Yeah. You could do all Fourier transforms in it and everything. It's really nice. Converts things to music.
Wow.
Because music is just the geometry we experience with our ears.
True. That's true.
And geometry, therefore, is the music we experience with our eyes. And I think you're right. It needs a whole new way of thought. The mod 24 is directly related to the E8 lattice.
Yeah. Yeah.
The 5, 12, 13, or the 10, 24, 26 triangle, directly related to the E8 lattice. It's the compression of it.
Yeah. Yeah. Incidentally, one fun fact, there's something beautiful about limits. Okay. And one important limit is, well, what is the maximum density like of spheres that I can pack, right, in a volume or an area? And so, of course, with circles, okay, the maximum density is the way you arrange circles on a piece of paper, and that
Sphere
gives
packing.
you the point set, which is this lattice that has that hexagon with the seventh point at the middle. But if you say, well, what about 3D? That's just the way they stack oranges in the supermarket, and that creates the cube octahedron as that root polytope. That's now goes from 6 points, doubles to 12. And then if you go to 4D, the maximum packing of spheres in four-dimensional balls gives you the lattice called the D4 lattice, and that gives us the 24 cell. And then for dimensions 5, 6, and 7, there is no maximal sphere packing known, and I don't believe there is a maximal sphere packing that's unique in the first place. Then the next dimension that has a maximal sphere packing is 8. And that in that 8-dimensional balls in their maximally dense motif gives us a point set where the spheres kiss, make points where they kiss. That point set is exactly what we're talking about as the point set of the E8 crystal, where the 1024 cells define the root polytope for that, which is remarkable, right? Because you're saying that the maximally dense point set for the 4D case, you need 10 of those rotated from one another in 8 dimensions, and then that maximally dense sphere packing point set composites up to the 8-dimensional maximal sphere packing point set. So sphere packing is a deep thing. Limits in general, you say like, what's the limit, right? The upper limit, lower limit, and usually you find some juicy stuff at the upper.
Usually Euler's in there. Whenever there's limits, Euler's hidden in there somewhere. Yeah. Did you say what was the fifth dimensional sphere packing?
So the in dimensions dimensions 5, 6, and 7, there is no known.
There's none. That's what I thought.
Or 8. What
about
7?
3?
7. There is no known maximal sphere packing, and there may not be a maximal sphere packing in the first place. It could be an infinity of motifs that have the same density, or it's an unsolvable problem, those type of things that people have been looking for years. But when you get to 8D, because it's part of these division algebras, so the division algebras are 1D, 2D for the complex numbers, 4D, and 8D. And for all 4 of those dimensions, we know the maximally dense sphere packing. That's A1, A2, which is the triangles with the hexagons with the points in the middle, and then 4D, that's the D4 root lattice. That's where the 24 cell is, the root polytope. And then
what about the third dimension? What's the third dimension one?
The third dimension is the way that we pack oranges in the supermarket, and that forms the root polytope of the cube octahedron. And
right.
That's 12. That's kissing number 12. So in one sphere that you randomly pick, you can say how many other spheres are kissing it. 12.
One of the mathematicians on my team lives in Brazil, and this is all they do is sphere packing for freight forwarding.
Oh, really?
So they do. Yeah, that's all they do. Her company is all just existing for this.
She's a mathematician?
For airplane packing.
They're mathematicians?
She's a mathematician, yeah.
Maybe
she's a mathematician.
We should talk to them about this. When we talk later, we can decide if we think that geometers like them might be something to team up with the number theorist. Because normally number theorists are not hardcore geometers, but anybody working on sphere packing problems are hardcore geometers. And again, because it's a geometry plus number theory mashup, I think that you and me, obviously, as non-PhD scientists, we have a balanced yin-yang the way we think between geometry and numbers. But these two characters they're going to not be as yin yang balanced as us, though. But to put them together, now we create the balance synergy.
Yeah, absolutely. And I've got some really good number theorists too. So
yeah, good.
And some physicists who are more like number theorists.
Good.
So that's what my team is. I have a team of about 20 mathematicians, physicists.
Hey, if you get a chance, when you get my emails, if you remember, shoot me a list of them, because then I can poke around on the internet and look at the papers they wrote. And in case of them, in case there's a synchronicity where any of them did some work that is like, could really complete something we're working on, I could say, hey, Robert, maybe I should talk to that person.
Yeah, the person you could look up a lot is Talal.
Yeah.
Talal Guanam.
Spell the last name.
Ghannam.
Okay. Oh, yeah, I see him here. He's an author of some stuff, at least the first one that came up. Oh, okay. Yeah, I see him. He's about 40, right?
He's probably 45 or 48
Okay, I
now.
think I got the right guy. Okay, cool. I will check him out. It seems like he wrote a he wrote a book called Philomath. That's definitely him. The geometric.
Yeah, he wrote it with me. Yep, he co-authored it.
Oh, right. Okay, this is my kind of guy. Okay, I'm gonna check out his stuff.
Yeah, definitely. He's a PhD. He taught physics.
Yeah.
And number theory at King Abdullah University, which is one of the top math institutes in the world.
Nice. I'm gonna probably order this book too.
Yeah, well, I'll bring you a signed one when I come to see you too. But
sweet.
I want to thank you so much for taking so much time with me. Wow, what a discussion.
Yeah, thank you,
And
Robert.
I'm really looking forward. I learned so much today. Thank you for finally, closing the loop on some things for me also related to the E8 lattice, which I was not fully aware of. And as you were talking, I was just getting like this chill up my back and shings all through my arms, which I know then the universe is like, listen to this.
Right. Nice. Yeah, I felt the same way with a lot of the things you said today as well. So beautiful. Well, thank you again, Robert. And
thank you so much, Cle.
Yeah, and I'm pretty much around all early summer and just whatever your schedule is. I'm pretty flexible. So, but let's start with that paper and riff from there. Yeah.
Yep. How can people follow your work?
Oh, thanks. So we have a lot of videos on YouTube. Please subscribe so you'll know when the new videos come out. And to find us on YouTube, the best way is you either put my name, Cle Irwin, or you could add in the words of our institute, which is Quantum Gravity Research. Sorry for the long name, but Quantum Gravity Research. That'll bring up stuff on YouTube. And then you should go to our website, which has all of our videos in one place, but it also gives you a portal to get into our scientific papers. And that would be quantumgravityresearch.org. And then the last thing is anybody wanting to sort of dip their toe in the water to our work should read a series of papers that you do not need advanced mathematics to understand, but these are the core. So that starts with the paper called Toward the Unification. That starts with a new approach to the hard problem of consciousness. One. Second, a new approach to, the next one is Toward the Unification of Physics and Number Theory. The third one is the Code Theoretic Axiom. And then it all culminates with the most popular paper that brings it all to a head, which is called the Self-Simulation Hypothesis, Interpretation of Quantum Mechanics. And then having read the three earlier papers, it'll be a breeze to read that. Again, most of these papers have no math, and they're easy to understand. If you just read it at speaking pace, most people can understand.
Excellent. Well, thank you so much. It's been such a pleasure. It was fun to riff on this stuff. And we'll see everyone next time on Think Tank. Have a great one.
Thanks, everyone.